Yeah, okay. Guess we'll start the class. Everybody ready to start the class? I guess that's one thing. I will start with a little bit of story, just in case people show up a little bit late. So one of the reasons I'm doing these attendance now is basically I'm trying to figure out a decent way basically to figure out who's going to come or who's not going to come. So it's really important to me with Silicon Dojo. The idea comes from, I've been doing YouTube videos since 2009 and basically having an open platform for people just to come and get education. And as I say, you know, a curb is too high a barrier for somebody in a wheelchair. And so the idea is how to make this as accessible to everyone as possible. And so what I'm looking at here is when I backpacked through India 20 some odd years ago, and when I was in Calcutta, it was hot as hell, and the USAID library was the only place that had air conditioning. So basically I trot into the USAID library and I say, I'm here for the air conditioning because it was so hot. And there's this wonderful little Indian lady behind the desk looks at me and goes, okay, 10 rupees. And then I look at her, and so at this point in time, it was about 45 rupees to the dollar. So it's literally like 20 to 25 cents. So I look at her and go, that's nice. I'm American. Can I just go in now? She says, 10 rupees. I'm like, okay. So because of the weird number, it's like 20 cents. Anyway, so I give her the 10 rupees. And then I'm like, why do you want 10 rupees, right? This is an American thing. 10 rupees literally doesn't matter. It's not even a quarter. And it was funny because her face like really lit up. And she said they had a problem with the USAID library because it had air conditioning. A lot of homeless people, a lot of homeless Indians came in and basically took a nap. And they wanted to be open to everybody, but you can't have a whole bunch of homeless people taking a nap in your library. And so basically she said that the people who made the decision were like, create an amount of money that's so little that anybody who actually wants to be here will pay it. But if you're homeless, it's going to be so high. Again, a little bit of a curb so that they don't come in. And it was funny because she got the biggest smile on her face. Because again, this is India where they have caste system. And she was like, it's great. It doesn't matter who you are. As long as you pay 10 rupees, you get in the door. And I always thought that was kind of an interesting concept. And again, that's what I'm trying to figure out with Silicon Dojo is like how to come to the 10 rupee point. Again, a lot of people say, well, just charge like $1 on Meetup for people. But if you don't have a PayPal account, if your Meetup account doesn't work, if you don't have a credit card for some reason, that's all like a limit to get you in. And so that's why I'm basically doing these RSVP things. Basically, it's really simple. You can come, and if you start no showing, then when we have more important classes, then that will basically be the block that won't allow you to get in. Because the issue that we're coming to is we're having our first full day class on the 17th. We're going to have a full day class on Introduction to Python and programming for AI. So it's going to take you all the way from variables to loops to function calls, all the way to work using Llama in one day. And like the issue we have right now is I have 30 people on the wait list. So I have 30 people signed up and 30 people on the wait list. And that's going to be the killer when you know a number of those people that are signed up aren't actually going to show up. So that's the important thing. Again, I'm going to keep harping up on the, if you're not going to come, make sure you kill your RSVP because this is going to become more important as we go. So anyways, soapbox. Let's see here, just so everybody knows, the main website for Silicon Dojo is silicondojo.com. If you go to silicondojo.com, you will see our current events coming up here. So again, we have that full day class coming up. We have the Introduction to Programming class coming up. One of the things to keep in mind, so we're about to start bringing these classes back to Asheville. So I'm actually from Asheville. I come all the way here to teach these classes, going through a whole rigmarole to do classes back in Asheville. So if you come to this page, do make sure you pay attention to where the class is actually at. So if you can't come to Asheville, don't sign up for it. But so we should start having a lot more classes here. Just so everybody knows, these classes I do record in the back. Gotta make sure that's recording. Afterwards, they are up here, so you can watch them later if you want to. We also have fireside chats here, and we also have self-study classes. So for like introduction to programming, Python series, SQL series, Bottle web app series, these are our core technologies that we use here. So you can come and just basically learn as you see fit. And those are there. And do remember, free to the end user is not actually free. If you click on that little link, it'll take you to our beautiful donor box page, and you can throw a couple of dollars in. We are marginally profitable. Like, I think I make enough money to like buy my wife a candy bar. So we are making that much money. So again, if you do want to throw money in, basically with this system, I don't want to ever have anybody not show up because they don't pay, but stuff does cost money. So anyways, There we go. Let me just make sure this thing's recording, because I can just see that I forgot. It is recording. Okay. Duh, come on in. Hey, your name is? Name? Ivan. Ivan. Gol? G-O-L? From Cary? Yes. Yes, okay, that is you then. With these books, you can take the paper, don't take the book. That's all I ask. So feel free to scribble and write notes and all that. The paper itself is yours. I need my own book. Wow, I feel like I'm at home. This is a complete utter mess. Okay. There are two books out there where the pages are screwed up. So if you have a book where there's scribble on the front, your pages are one off than mine. But you would see, it would actually be scribbled on there. There's only two of them. Someday I will be able to actually pay for an editor or such. Okay, so let's talk about Raspberry Pis. Okay, so when we're talking about Raspberry Pis, we are talking about these things. So these are basically low-power computers, but they are full-fledged computers. So these are actually ARM-based computers. Generally, they have quad-core processors on them. They have full Wi-Fi stacks on them. You can run Linux, so this is actually running Linux on it. You can run Ubuntu, so Debian Linux. This is Raspberry Pi OS that is running on here. This is actually a distribution of Debian, so basically all of that can run on here. So you can run web servers on here. You can run most Linux software on here if you want to. This is not a microcontroller, so a lot of people say, oh, Raspberry Pi and Arduino, the same thing, and they're absolutely not the same thing. A microcontroller, basically, you put in the programming and it continuously runs through a loop, so it's essentially just continuously looping and looking for sensor values and that type of thing. You can get some functionality out of a microcontroller that looks like a server. I mean, very, very technically it is a server, but it's its own weird little thing. So this actually runs an operating system on it. You can actually hack this thing, like outside people can hack this thing. It can be a security vulnerability and the whole 9 yards. So basically what we're going to be talking about today is how do we use Raspberry Pis to push artificial intelligence to the edge. Because one of the things, like you look at a little Raspberry Pi, like one of the issues we have now is you have Sam Altman coming out and saying we need $1.4 trillion in CapEx expenses for AI, and you think you have to have a $40,000 GPU just to be able to run, artificial intelligence services. And what's actually really cool is it's amazing how much stuff you can actually run locally in a Raspberry Pi. IBM has what's called the Granite model, so it's an LLM model. The Granite 3 model that we'll be using today, the 2 billion parameter model, literally runs on a Raspberry Pi 5 locally. So you can actually get that to go. The other thing to be thinking about too is when you start building systems, it's called systems architecture. So one of the things you can do is you can have your little Raspberry Pi communicate up with OpenAI or with these other AI services. And even though this doesn't have very much horsepower to it, it's basically just acting as a conduit to their, trillion-dollar infrastructure so that you can get the results of that infrastructure on your little system here. So that's what we're talking about with the Raspberry Pi. The other cool thing with Raspberry Pis, if you don't melt them, this is a really cool project that Magic Smoke came out of earlier tonight, so we're not going to use it. But this is it was a full-fledged robot. Basically, it's running the OpenCV computer vision model on here in order to detect faces. And so what's cool is it will detect a face, it will detect where the face is on the x-axis, and then it will literally turn. So all of this is being powered off of simply a USB battery, a standard USB battery pack here. So the computer, a Raspberry Pi 4, is powered off of this. The webcam is powered off of this. Even the motors are all powered off of that little USB power supply back there. And so it can turn, it can move forward, it can move backwards. It's a completely autonomous robot. And so that's the thing to be thinking about too, is when we start thinking about architecture and you think about deploying systems, think about power resources. Right? So literally a Raspberry Pi, you can power off of a $15 solar panel. So you can get one of those solar panels off of Amazon, plug it into one of these things, and literally put it out into a field or something, and you would not be able to do that with a $40,000 GPU. And so again, that's the kind of stuff that you need to be thinking about when you think about building and actually deploying these types of systems. So that's why we care about the Raspberry Pi. Any questions, basic questions on Raspberry Pis? Jeez, fuck, oh, that was your computer. I was like, I hope that's not your computer. No, that was your computer. Okay. So first thing we're going to talk a little bit is about setup. So this will be at page 2. If you understand systems administration, this stuff will be kind of simple. If you don't understand system administration, don't worry about it right now. So basically, when you install the Raspberry Pi OS, and we're going to talk about that later, and you initially get it up and running on the system, you're going to want to make sure you do sudo apt update and sudo apt upgrade. So this is going to update your system to all of the current stuff. Especially in the Raspberry Pi world, make sure you update your system to all the current stuff, because it's amazing what breaks or just simply will not work if everything is not completely updated. The next thing is to remember, so in the Raspberry Pi world, when you're dealing with Python, you are going to need to use a virtual environment. So in a lot of our classes, well, classes I've taught previously, not here, in a lot of classes I've taught previously, I've thought it was easier just to not use virtual environments. So a virtual environment is an environment that only contains the modules that you've installed for this particular project. So normally I don't create virtual environments just to make life a little bit easier. One of the important things to understand with Raspberry Pis is you just simply cannot install modules directly onto the system. You do have to use a virtual environment. Where this becomes important, and that's what you'll see under create a virtual environment, you'll see the Python 3 space -m, venv, so that calls the virtual environment module, and then venv. So this is just the folder that we're going to call for the virtual environment. You're going to see beside that it says space or -- system -site -packages. Don't forget that. Basically, if you write out the code today and you create one of these fancy projects and then none of the damn thing works, before you go back and start rewriting your code, make sure you create your virtual environment or recreate your virtual environment. See, the thing is, on a Raspberry Pi, you can install many different operating systems. You can install Ubuntu. There's like 50 different operating systems you can install. The important thing about the Pi OS and why you want to do this in the beginning is this has all of the fancy drivers and software to make all of the components on here work. So one of the important things with Raspberry Pis, these are called GPIO pins up here, general purpose input-output pins. And so this is how we can connect what's a PIR sensor, a motion sensor. This is how we can connect LEDs. This is how we can connect an I2C screen. If you don't do that site packages thing, you don't get any of those modules. Not only do you not get the modules, but it doesn't even understand how to use. So even when you install what's called the GPIO 0 module, it doesn't understand the numbering system, and it gets to be a complete and utter disaster. So the big thing to remember is when you're going to create the venv, make sure you do it with the system site packages. And then when you're going to run, because you're using a virtual environment, make sure to do source venv bin activate, and that's what activates your virtual environment. So you'll see down here, this venv before my prompt, that means I'm in the virtual environment. So again, if I run my code and nothing works, most likely I'm outside of that virtual environment.
Real quick.
Yep.
Just to reiterate, so you're saying that flag, that system site packages flag,
yep,
that basically gives your Raspberry Pi OS modules to the virtual environment has access to the.
So what it does is it copies all of those to your virtual environment. Yeah, yeah. So, yeah. Grab 2 and, oops. You are again? Ram. You are.
RAMKUML.
All right, yep. Ram. Cool. And you, Michael. Michael North.
D.
D? Dakney?
Yeah,
Dakney. Cool. Okay. So yeah, we are on page 2. So anyways, yeah, so that's going to copy all the site packages in, so just make sure you do that or it's a disaster. Let's see here, speech to text. So we're going to be doing a lot of things with our little Raspberry Pi tonight. One of the things we're going to be doing is speech to text. You're going to be installing something called Pi Audio. So everything here should work on the Raspberry Pi. Again, lived experiences in the tech world, you have not lived until you've tried to install Pi Audio on multiple systems. So what Pi Audio does is basically it allows you to take audio from the microphone and then use Python to do something with it. So Pi Audio is a package that allows you to do that. On Raspberry Pi, hopefully the sudo apt install Python 3 Pi Audio will do everything you need for you. When you start using this on Mac and you start using this on Windows and you start using it on other OSs, it can be a bit of a disaster. So that's just one of those things. You're going to install OpenAI Whisper. So that module there is really cool because basically with OpenAI Whisper, you can actually do local voice recognition. So it does not have to go off to an API. Everything, the voice can actually be turned to text directly on the Raspberry Pi itself. We are using a Raspberry Pi 5 tonight. Install sound file. That's just a module you need for Whisper. And install FLAC. That's something you need for Google speech to text. So when we use Whisper tonight, that is going to be a local model that's actually running on the system itself. When we use Google's voice API, that's going to actually be going up to Google servers, and then we're going to get the text back. The thing with the Google API is nice is basically it's an open API key. So as long as you don't use it in production, it shouldn't break on you. Again, it is the type of thing, though, if you're running your code, if it was working perfectly yesterday and it starts failing today, they might have done something wonky with the API key. Just something to keep in mind. For Ollama, so Ollama is going to be the local model. Oh, everybody's showing up. Ah! All right. One for you. Throw that back down. I forget you. Who are you?
Aaron?
Aaron.
Came a month ago. I don't know if you...
Michael. Okay. Aaron Michael? Yeah, you. And you are over there. Danielle. Danielle W?
Yeah.
You were in No Show last time, weren't you? Yes, you were. Oh, well, no, I will. Again, I was giving them this whole speech. You don't have to pay anything to come here. There are no grades. No-shows are going to be the ding against people. If you get a no-show, it will cause you problems in the future. You're all adults. You do with that as you will. Okay, so we are on page 2. If you guys have the books, we're basically talking about setup. Installing Ollama on one of these little guys, you're going to go to the command line. You're going to use something called curl, and you're basically going to put in that command. That's going to install Ollama for you. For the project tonight, we are going to be using the Granite 3 model, so 3.3 2 billion parameter model. This is IBM's model, so since we're around the Research Triangle area, woo woo, IBM, works really well. I do have to say, I have been incredibly impressed with this model. This model is small enough, it runs locally on a Raspberry Pi, and if you haven't played with it, you definitely should play with it. We have been using something called Pi 3 as our default model here in class, which, to say it's wonky is being very kind. What I find is the Granite 3 model is actually good. It actually does what the hell it's supposed to do and doesn't need very many resources. We're also going to be using the Lava model. When you talk about Lava, this is going to be a vision model, so it can actually process what it sees on the camera locally. So that's Lava. And then when you're going to be running Ollama from Python, you do need to install the Ollama module into Python. OpenAI. So basically, when you do Ollama, all of that is going to be run locally. You do not need an internet connection. For OpenAI, so this is the OpenAI API. Basically what happens here is the system takes information in, sends the information up to OpenAI. OpenAI then sends back the response. Basically, if you want to do OpenAI, you have to install the module, and then you do have to go and you have to actually get an API key from OpenAI. So basically, you have to dump $10 into your account. That doesn't cost very much. I go through about $10 every year. That's about, you get a lot of tokens for $10. The final one, and again, this is another wonky one. Text-to-speech with PyTT-SX3. So this is a module that we are going to be using. So you install the module, that is what it is. Oh, lordy, this was miserable. Okay, so you're going to see sudo apt install -y pipewire -alsa. So this is one of those weird things where software changes over time. For some reason, when you use PyTTSX3 as the module, the default audio isn't right. So however this module is coded, it is supposed to go to an ALSA output, whatever the fuck that means. But basically that was the default output a couple of years ago. They decided that they were going to upgrade PyOS and make it better. So now instead of using ALSA as the default output, they use something called Pipewire as the default output. And so you get this really weird issue where audio works on your Raspberry Pi. The eSpeak, which is the software that allows the thing to speak, will work on your Raspberry Pi. All the audio works on your Raspberry Pi perfectly until you go to run the module and it's completely and utterly silent. Because when you run the module, it's going to the wrong output, and that's why you have to install this. So if you run your code and you're not getting any output from the module, do that, install Pipewire ALSA. And then also under that, you're going to see sudo apt install eSpeak, libspeak1, and eSpeak-ng. This is actually pretty cool software. So this actually allows at the command line for your Linux box to actually be able to output audio. So you can type in hello world and it'll go hello world, and that's how it goes. Any particular questions on that stuff? Yep.
I wasn't following the instructions before the class on the Mac.
Yep. Oh.
Virtual environment. Everything worked except for that Pipewire also.
Oh yeah. So that wouldn't work on your Mac because that's a Raspberry Pi only.
Dash Y was not valid or something.
Dash Y isn't? That's just yes. That's just agreeing to it. Yeah, I don't know. But yeah, no, the Pipewire to ALSA, as far as I know, that should only be Raspberry Pi. You shouldn't need it on a Mac. Yep. Cool. Okay, so let's go to page 3 and talk about Pis. Now get your hands on Pis. Okay, so up here we have a Raspberry Pi 5. I've only got one of those because those are kind of expensive nowadays, so you don't get to touch one of those. We have a Raspberry Pi 4 here. We have a Raspberry Pi 0 W version 2, Raspberry Pi 0 W version 1, and we have a Pico. I'll let you guys touch it once I'm finished here. So basically when you're dealing with the Raspberry Pis, the first version of Raspberry Pi you're going to look at, these are called the 0 series. And basically with these, you've got a 1 gigahertz processor on here, you have 512 megs of RAM, you have a full Wi-Fi stack, you have a full Bluetooth stack, and they're actually pretty impressive, right? If all you need is an endpoint for doing things like taking pictures, being able to input audio, that kind of stuff, the Raspberry Pi Zeros actually work really well. The first version came at $10, so these are incredibly inexpensive, $10 for one of these things. Version 2 comes in at $15. Now, one thing you'll notice is this doesn't have what are called headers. So if you're going to go to Adafruit or wherever you're going to buy these things from, pay for the headers. It costs $5 extra for them to solder the headers on this thing, and unless you love soldering, it's going to be worth its weight in gold. So that is one of my warnings for you, because again, if you're going to want to connect anything to the GPIO pins, you need these, what are these called, headers. So if you have this, you get to take out the soldering iron and solder in 40 pins and hopefully you don't screw anything up. So pay the extra $5 there.
That's what is that again?
So this is a 0W version 2 with headers on it. So this is $20 a piece.
With the header.
Yeah, with the headers. Yep. Now also one of the weird quirks, again, the technology world. People say, Eli, I want to do technology because I'm passionate. And that is how you know they do not actually do technology. This is misery. This job is misery. So anyways, I have a number of these from years ago, and for doing the class tonight, I didn't want to buy any of the new ones. I don't need to buy them. This is not functionally that much better than this one. Why am I going to spend an extra $20? Oh, I got to learn. So this uses something called ARM v6 architecture. This uses ARM v8 architecture. Who the hell cares? Well, a lot of stuff cares. Weirdly enough, so when you use VS Code, so our default IDE is VS Code, you can use something called an SSH extension to go into a Linux machine to be able to edit things on Linux machine directly in VS Code. VS Code extension does not like ARM v6 architecture. We have another lab where I just want to open up a web browser just so you could see the outputs coming out. ARM v6 architecture does not like web browsers. I was like, okay, that's fine. I'm tired. Look, I'm just going to install the OpenAI module onto this thing so I can do OpenAI API calls with this. OpenAI module does not like v6 architecture. So if you have a version 1 of these things, God help you. You may have some very bizarre problems. So this uses what's called a V8 architecture, and everything should work fine for you. Let's see, one of the weird things with these, if you do buy a Raspberry Pi Zero, is it uses something called USB on the go. So if you have better eyes, I am getting to be about 50. Anyways, so you're going to see 2 little USB connectors on here. Again, you have to be careful with all this kind of hardware. One of these USB connectors is only for power. It is not actually a USB connector, it's a power connector. Then the other one is actually for USB. So what you need is a dongle for USB on the go. Basically what happens if you're trying to figure out how to plug in a mouse and a keyboard and everything else, you get one of these little widgets, you plug this little widget into here, and this is how you get all of your USB connections. So again, that's one of just the weirdness of these little guys. And then the other thing too is whenever you're dealing with Raspberry Pis, for whatever reason, they all change what the HDMI port that they use. So some use micro HDMI ports, some use mini HDMI ports, others use full-fledged HDMI ports. So if you buy a Zero, you're going to need a mini HDMI connector. Whereas if you have a 4 or 5, you need a micro HDMI connector. So that's the kind of fun stuff that you get. Here, I'll let you pass those around so people can see what they look like. Okay. Then past that, we go to what is called the 4B. This is kind of the standard that has been around for a number of years. These are pretty affordable. And for most projects, these are going to be fine. It's a quad-core processor. What does it say? It's a quad-core 1.8 gigahertz processor. So actually for a lot of things, it works really well. You can get these in a number of RAM sizes, all the way from 1 gig of RAM all the way up to 8 gigs of RAM. One of the things that I will warn you about with Raspberry Pi right now is they're starting to get cheap with RAM. And so, like they're now selling Raspberry Pi 5 versions with 1 gig of RAM. Let me tell you, for most people, that is a doorstop. Like the processor is fine, that's just not enough RAM to do very much of anything. So one of the things I would tell you is if you want to start playing with Raspberry Pis, especially with 4 or with 5, get it with 8 gigs of RAM. Make sure it does whatever the hell you want it to do, and then you can optimize down to smaller ones later. Because if you get 1 gig of RAM and it doesn't work, then you can't upgrade it. It's all soldered on the board. It's got a 1 gig NIC on it, which is nice. It has multiple video outputs. Has 802.11 AC, so that's actually very good. Wi-Fi stack and Bluetooth 5. With these things, they do take a USB-C power supply, but the cool part is you can literally power one of these things off of a battery pack, and it will last for an amount of time. So this is what we're talking about when we're talking about Raspberry Pi 4s.
Is that a kit?
What's that?
The card. Did you buy that as
No, I built all that. Yeah. So there we go. Then we get to the Raspberry Pi 5. Well, that's the cool one. So this is the current model of Raspberry Pis. They cost all the way up to $160 now. They are getting to be a bit expensive depending on how much RAM you want, because you can get them with 16 gigs of RAM. Now, one of the things I will tell people is, I'm out of all my Raspberry Pis. Anyway, you'll hear a lot of people on YouTube. So I am a YouTube creator, so I know how YouTube works. And basically, we say stupid crap for money. Just if you go to YouTube videos, like, don't trust any of us. We're saying stupid things for money. One of the interesting things is you'll hear a lot of people on YouTube, and they'll say, Raspberry Pis are not worth it. Buy a mini PC, right? So there's these mini PCs out there. They're called nukes. For anywhere from $150 all the way up to $1,000, you can buy these things. They actually have full-fledged x86 processors on them, a decent amount of RAM, decent amount of storage, the whole 9 yards. And so as a computer, they do generally work better than a Raspberry Pi. So if you need a desktop computer, you would definitely buy a micro PC over a Raspberry Pi. But they do not give you GPIO 0 pins. You cannot run them off of a USB power supply. Basically, they are entirely different critters. So again, one of the things to be thinking about whenever you're developing whatever project it is you buy the hardware based off of what you're trying to build. So like with this here, again, I have a PIR sensor connected, I have screens, I have LCD. This thing is going to power my light. I can do all of this with a Raspberry Pi. even if the mini computer is much more powerful and less expensive than this thing, I just simply can't do that with a mini computer. So one of those things just to keep in mind. One of the big things with Raspberry Pi 5s, it sounds stupid, again, unless you've been in the tech world for a while, is they have real-time clocks. Woot, woot. I know, nobody gets excited about these things. It's so funny, like people are like, have you heard the new AI model? I'm like, I don't care, it has a real-time clock. Okay, real-time clocks are incredibly important. So what a real-time clock is something that you take for granted. Every computer in the past 40 years has a real-time clock other than Raspberry Pi 4s and the others. What this is the clock on your computer that just literally is a clock. Why this is important is because timestamps are an incredibly valuable way basically to identify things like data within your system. And so if you have a Raspberry Pi 4, every time you power it down, when you power it on again, the clock essentially goes back to 0 or resets to whatever it was. The cool part with a Raspberry Pi 5 is you can plug a battery into it. It will have a real-time clock. And so if you're using timestamps for any kind of identification, you can actually continue to use those timestamps and you're not going to run into really wonky-ass problems. So again, real-time clock. It also has a PCIe 2.0 connection, which allows you to add things like M.2 storage. So you can put multi-gig drives on these things if you want to. And it actually allows you to run external GPUs. There is a YouTuber called Jeff Geerling. If you haven't watched him, watch him. And he plugs $2,000 GPUs into Raspberry Pi 5s for some strange reason. So that's one of the things that the PCI Express port gives you. Yep, that's about what the Raspberry Pi 5 is, and again, that's what we're going to be working on tonight. Then you will hear about the Pico. So this is created by the Raspberry Pi Foundation. The important thing to understand is this is a microcontroller. So when they say, should I buy a Raspberry Pi Zero or should I buy a Pico, it's what is your project? So again, with a microcontroller, you just write the code, it essentially continuously loops. That's all it is. It's not a real computer, and so if you buy a Pico, just realize that's its own little critter. We will have a class on another time. Any questions on that? Nope.
Sorry. So basically everything in here, they all work for the compute modules too?
The what?
You know the Raspberry Pi compute modules? All this should work on the compute modules too? You know that little module is basically just an eye on a board that you insert into a carrier board. Compute?
No, the compute, okay, so the compute module, that's its own critter. So basically what the compute module is, what he's talking about is that is real and people do use it. It's more for industrial use cases. Yay, come on in. Let's see here. So the compute module, basically what those are is they're for industrial use cases. So imagine you need compute functionality out of your project, but one person wants to create a surveillance system and another person wants to create like a networking device. What's really cool with the compute module is people can create their own carrier boards, right? Vendors create their own carrier boards with specific hardware components on it, and then you slap the compute module onto that, and now you have those external resources. So that's its own deal. So basically the compute module is the compute stack of a Raspberry Pi on a card that you then slot into other hardware.
Yeah, right.
Yep.
But all the code you wrote here should work for the compute module. Right? It can still run along with it. Should is dangerous. Those are dangerous words right there. Did you hear me just lose my mind over the V6 architecture? That was a real thing. That was about a day's worth of what the ever-loving hell was going on. So yeah, try. Sorry, what was your name?
My name's Nick.
Nick, cool. Nick Knapp. Okay, go down. Okay, so we are on page 4. Okay, and so Nick, you can write and scribble on this. You can take the paper, don't take the book. As far as the Pi operating system goes, basically when you install it, it is going to be different than how you normally install operating systems. So on your main computer, you are going to install the Raspberry Pi Imager. So there's a software here called Raspberry Pi Imager. And basically what you're going to do is you're going to take your micro SD card, you're going to slot that into your computer. You're then going to select what Raspberry Pi you have. You then click Next. You're then going to put in what operating system you want. So you can see that there are multiple different operating systems. So you can put Ubuntu on there, Alpine Linux, the rest of it, whatever. And then you keep going through, and then you install it onto, so what it does is it images it onto that micro SD card. Once it's done imaging onto the micro SD card, you pull it out, you plug it into your Raspberry Pi, you boot up your Raspberry Pi, and you go through some finishing procedures. So that's basically how you install. It's not how you install most operating systems. Yep. The big thing, again, when you're going through here, and the whole question is, like with me, I personally like Ubuntu. So if you're like, well, I already know Ubuntu, why am I going to use PiOS? The main reason you use PiOS is for access to things like those GPIO pins. So PiOS has the GPIO pins all installed. There are ports in here for a camera. So you can slot a camera directly onto the board. You can connect displays directly onto the board. So all of those drivers and softwares are in the Pi operating system, where they're not necessarily going to be in the Ubuntu operating system. So if all you're going to do is create a web server, you might not care about the GPIO pins, use Ubuntu. If you care about the GPIO pins, use PiOS. PiOS, again, is a Debian distribution. So if you know Ubuntu, if you know Debian, it's basically the exact same commands. Sudo, apt-get, apt install, that type of thing. When you talk about hats in the Raspberry Pi world, these are, more hats. Basically what these are essentially like PC cards that go on top of the board. So you've got the headers over there. This is also, you need those headers if you want hats. Basically this connects on top of the board, and then this gives you additional functionality. There are 1,000 different hats out there, so you can just kind of Google search what you want. This is a really cool, it's an LTE hat. So basically what I can do is I can actually connect this to my Raspberry Pi, and then I can send commands to this over the LTE network, so over the cellular network, or I can actually have my Raspberry Pi send information over the LTE network. So again, something to think about, like when we start talking about artificial intelligence and rethinking how computers operate. Like if you have a camera computer, the way we normally think about a camera and a computer is, okay, I'm going to send that video stream back to some kind of security office. But the thing is, to send a stream back to the security office, that's going to cost like a 1 megabit per second footprint. So basically, the video stream that goes back is going to take a megabit per second. So that might get a little bit expensive. One of the cool things that you can do with AI is if you have a vision model on this thing, you have a motion sensor, it takes a picture when somebody walks by. It can then analyze the picture, create text about that image, and then send that text over your LTE connection. So I just saw somebody in a uniform, not in a uniform, in this sector of our campus, and that might be something to send a security guard out, something like that. So anyways, so basically you got hats. This is a little hat that allows you to put speakers on your Raspberry Pi. The reason I brought these two hats today is you'll notice that this hat has header pass-through. So you slot the headers in the bottom, and then you can continue to use GPIO pins on top. You'll notice this particular hat does not have header pass-through. You put this on top of all of your GPIO pins, and you don't get to use any more GPIO pins. So something to think about. The other thing to think about with these hats is that when you look at their documentation, they will tell you what GPIO pins these hats are using. So basically, when you plug this in, they're going to use one or more GPIO pins in order to communicate with your Raspberry Pi. Well, with your project, if you just happen to use the exact same GPIO pins for other things, all hell can ensue because now you have a conflict on the GPIO pins and whatever. So things to think about. So these are hats. You can pass those around. And then finally, we've got modules. So modules are all kinds of different modules. So they can be screens too. So basically, when we talk about modules, so this is a GPS module. So the modern world, so I bought this one for about $30 about 3 years ago. So this can actually give you full GPS functionality for your device. It tells you your lat long, it tells you what speed you're going, gives you some other interesting information. You can have a module like this. Basically, this is an ultrasonic distance sensor. It uses ultrasonic sound waves essentially to figure out how far something is from your device. You have an infrared sensor here, so basically it's just an on-off. This is an infrared emitter. This is an infrared receiver, I think. Anyways, basically the light goes out, and then when an object gets close enough, the light reflects off of that object, and then the receiver then receives the infrared, and it knows it's close to an object. So basically it's on-off. And then we have, this is what's called a PIR sensor, a passive infrared sensor, and this is what you consider a motion sensor. So when somebody goes walking across, theoretically it's going to detect somebody walking across, and it's going to trigger. There we go.
Did you say this one does with the pass-through?
That, so the pass-through is the touch. So basically, see how those, yeah. So you can.
What does this board do?
So that is the LTE. So that sends communication out over the cellular network. Yep.
Are all of those made by Raspberry Pi as well?
No. So Raspberry Pi makes very few. Yeah, that's an odd as a speaker. Yep.
I mean, that's the name he asked.
Oh, Pi Audio, yeah. No, Raspberry Pi actually makes very few, I guess they don't make few, but they do make accessories, but not a whole lot. So a lot of these accessories are going to be made by third parties, especially when you start dealing with with the sensors and things. You just go on to Amazon, and basically the Chinese factories are just ripping these things out. There's like 50 different versions of the exact same thing.
So instead of hearts,
What's that?
so you have hearts, right? So instead of hearts, I can just use the USB connection, right? I can connect multiple devices like speakers, modems to it.
Yeah. So I have like a USB. So this is a
I
USB.
don't need to use the hearts everywhere.
You need to use the hats for the things the hats need to be used for. So like the LTE connection. So that's a hat. Or like motors. So this thing here, to be polite, is very janky. There's something called pulse width modulation, is how you determine the speed of motors. So on the board itself, it uses software pulse width modulation, which works. It does work, not very good. So you can add a servo and motor hat to this thing, and that actually gives you hardware level pulse width modulation. So if you're actually dealing with robots where you need to be precise, then you would do that. So it's like, again, it's one of those, you use hats when you need to use hats. And your name is? Akash. Akash, there we go. Okay, we are on page 4. Okay, so we talked about the modules. So then let's take a look at GPIO pins on page 5. Let's pull this up. So when we take a look at the top of the board, these are going to be your GPIO pins. You're going to notice there's 2 numbers here. So you have to be careful about this. So when you look at the numbers here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth, these are called the board numbers. And what the board numbers are is very precisely, it's the number of the GPIO pin on the board. Duh. Anyways, the curious thing about this is these down here, I think they're called the Broadcom numbers, if I'm correct. BCM numbers, basically come from Broadcom. These numbers actually correspond to what the board number connects to, like on the processor. So if you're using different Raspberry Pis, so like the difference between like Raspberry Pi 4 and Raspberry Pi 3 is that the Broadcom numbers are going to be going to different board numbers between those 2 devices. So basically, if you're going to be writing code that's going to go in a Raspberry Pi 3 and a Raspberry Pi 4 and a Raspberry Pi 5, you use this GPIO number here. So GPIO pin 27. So 27 corresponds with board pin 13. You use pin 27 because basically what you can do is in your code, you set 27. And then if you look at the schematic for Raspberry Pi 3, 27 might be pointing to a different board number, but you just plug it in there and everything will work properly. It's a very convoluted way of saying just use these numbers down here. Basically, don't use those numbers there. You will notice with this, there's a lot of weird stuff in here. Board pin 1 for the Raspberry Pi 4 is a 3.3 volt power connection. So this is where you can actually pull power directly from the board to power your sensors or whatever. And you'll notice board pin 2 is a 5 volt power connection. So this will be important depending on the sensors and the modules that you use. Some sensors and modules require 3.3 volts, some require 5 volts. I don't know, look at the specifications, they'll tell you. If you plug in a module and you're getting readings, but they're wonky, one of the reasons might be is because you basically plugged it into the wrong power. One of the things to keep in mind. You've got these, this SDA and the SCL pins up here. This is for something called the I2C Electronic Communication Protocol. We'll talk about that in a second. So these are those pins here, and basically go down, you can see there's different pins. You got another 3.3 power supply here. You have ground here, you have ground here, you have ground here, you have ground here. So basically if you need to power your modules, you just figure out where to plug in the ground and where to plug in the 5 volt connections. With that, basically the module that you're going to be using is, in order to connect to the GPIO or the GPIO pins, is a module called GPIO 0. That's the module that we use. That's the module that everybody uses. If you need information on the GPIO 0 module, basically you can click on that little link and it will take you to the web page, and when you're here, it'll actually give you a whole bunch of stuff about how to build things using the GPIO 0 module. So you can just go here. It explains pin numbering for you. It explains to you, again, the first thing for how to connect an LED to your board. It shows you about PIR sensors and a whole bunch of different stuff. It shows you how to do a button, that kind of stuff. So anyways, so if you need more information on the GPIO 0 and how all of this works, you can come here. This is where you do need to start buying some electronic supplies if you're going to start building projects. This is something called a breadboard. So this is your little project board that you're going to plug everything into. So if you see this is my little breadboard here. So I can have power that comes to it. I have my little LEDs plugged into it. This is how you can kind of connect little electronic devices together without soldering them together. Okay. Questions on GPIO pins?
I'm assuming all those PCM numbers are like an industry standard.
What's that?
The PCM numbers, the book numbers?
Oh, they are.
Like an industry standard?
Are they industry standard?
I'm assuming that the project with like Arduino or ESP.
No. Because it's an Arduino or Raspberry Pi.
What?
Is a Raspberry Pi. What's the difference between a Raspberry Pi and an Arduino? I'm going to start testing you people. This is how people get tests and quizzes. You say things 5 times. So remember, a Raspberry Pi is a full-fledged computer. You actually have an ARM processor, you can install Linux, you can do all this fancy stuff. When you talk about an Arduino or a Pico, Raspberry Pi Pico, these are microcontrollers. Basically, a microcontroller, all that does is loop. You have a little, what's called an IC chip. So technically, it's a computer chip, but it's not a computer chip. You have a little chip on there, basically continuously loops. So Raspberry Pis and Picos and Arduinos essentially have nothing to do with each other. Basically, if you find something where they're alike, you're lucky. And it's its own thing. Yeah, no, they're their own critters. The only way with what you're talking about might be accurate, maybe, I don't know, is there are other microcomputers out there. So there's something called the Banana Pi. There's something called, I think it's called the Beagle Bone. There's Libre PC. Basically, people like this idea and they created their own versions. So this might look a lot like what they create. But that, again, those are full-fledged computers that happen to be small. Okay, so let's talk about I2C Communication Protocol. So we're going to be on page 6. So the I2C Communication Protocol is absolutely terrific. Basically, what this is a communication protocol for electronics devices. You're able to connect up to 127 devices per widget, per computer. So if you want a lot of sensors, if you want screens, so this is an I2C screen, that GPS board I have around that's called an I2C. And the nice part about that is basically all you have to do is power it. You power it, you connect it to the SDA connection, and you connect it to the SCL connection, and that's all you have to do. So you can have up to 127, theoretically, of these devices on your project. The weird thing about the I2C communication protocol is it is an addressable protocol, just like TCP/IP is an addressable protocol, sort of, right? The difference, though, is in most of these devices, the address is hardwired into it. So one of the issues you run into is like, what if I want 5 different I2C screens running that are showing different things? Technically, you can do that, as long as they each have a different I2C address. And depending on the manufacturer, that might not be something you can do. So like most of these I2C devices, the address is hardwired into it. With some of them, you'll notice jumpers in the back that allow you to change the address a little bit, but it's one of those tweaks just to be thinking about. The big thing, and again, is we have a normal screen here. This is a normal LCD screen. This is an I2C screen. If you'll notice on the back, this has 10 pins you have to figure out how to connect to a breadboard. And as I say, this has 4 total. So that's one of the nice things with I2C. When you're going to be using the Raspberry Pi, one of the weird things with a Raspberry Pi is not all the ports are active when you install it, for whatever reason. Who the hell knows why? So one of the things you need to do is you need to do sudo raspi-config. I think it's raspi-config. And it's going to take you into this screen. Then you're going to go to number 3 for interface options. And here you're going to go to I2C. And basically, I'm not going to click on it so it doesn't screw everything up. You're going to go here and you're going to turn on the I2C connection on your board. If you plug everything into your board, you do all your code, nothing works, it's most likely because you forgot to turn on your I2C connection. Again, one of those weird things there. Let's see here, control, tab, finish. In order to get I2C to work, you do need to do the sudo apt install I2C tools, and that will actually install the I2C tools for you. You do have to install that. And then in order to figure out what the address number is for an I2C device, that's where you use the I2C detect command. So I2C detect Y1, and let me shrink this down. So basically what this is going to show you is this is going to show you all of the different I2C devices that are connected to your system. And as you can see, this particular address for this little guy is 27. So basically, if you plug a device in, it powers on, everything seems to be right, but again, the code isn't working. Most likely you put in the wrong address, so you run I2C detect, and you figure out what address you're supposed to put into your code. And I will show you that in a few minutes. Any questions with I2C? No? Okay.
What is this access? 0, 1, 0, 0, 0, 1?
What is that?
The access.
Oh, you guys always ask me the question. I don't know. This is just what they show you. Just worry about that number.
So the left is just address is 10, like the row is 10, and then it'll be like 27. On the left there is a 2, 0, there is a 7.
Yeah.
Okay, makes sense.
Yeah, so it's around 10.
I got it.
Yeah, what he said. I don't know. That's what sucks with being a teacher. You spend 2 weeks creating class, and somebody's like, "What about that?" You're like, "I don't know." That's
time fiddling with all this stuff.
yeah. Fair enough. Okay. So the next thing is we'll talk about the camera a little bit. So one of the cool things is you can connect a camera directly to the board. So when you got these cameras, they've got lots of different cameras out there. So the cool thing is there's a company called ArduCam. If you want to buy a camera for your Raspberry Pi, go to ArduCam. They only cost about $9 or $10. Official Raspberry Pi cameras cost you $30, and they're basically the same thing. So ArduCam is not a rip-off company. They're actually a real company that produces a hell of a lot of cameras. So you get a good quality camera, you're not ripping anybody off, and it costs you a third the price. So that's the normal standard camera. What's kind of cool, though, is you can use different cameras on your Raspberry Pi. So this is a super night vision camera. So basically it's an infrared camera with massive infrared flashlights essentially on it. So you could put this up on a surveillance camera and be able to see in the dark. So these cameras are out there. This is a wide angle camera. Resolution is hell. But basically, you get a 180 degree field of view, or 300, whatever that is, all around. So I like this one. I used to create little robots to drive around so you could manually drive the things around. And one of the things that I found is a normal camera actually doesn't give you enough of field of view. I would actually be running into things I shouldn't be running into. And so simply by doing a wide angle lens, that gave me my entire field of view so I could drive the vehicle around a lot easier. So those are some of the things to think about. Basically with that, it's not additional drivers. You basically just pay for them, install it, and you get a different camera on it. If you want to make sure your camera works, you got two commands here. So RAPI R-A-P-I, cam. So this is just a command that you can run at the command line to make sure that your camera works. Oops, did I? RPI, oh yes. There we go. Try to be smart. There we go. Okay, let's make sure your camera works. Yay, camera works. This is weird. This is kind of a new thing. So the camera used to fire off a lot faster. Apparently what it's doing right now is it's actually trying to figure out the white balance and the contrast in order to give you a better image. So it will not simply take the picture and be done. It takes however long that was. That's about how long it takes to take a picture. So again, one of those things to be thinking about is if you're going to have this in an automatic device and it's taking a picture when something happens, it's about a 5-second process for that to occur. Whether that matters to you, it doesn't matter. Who knows? We have the other command here in order to actually take a picture. So RPI cam hyphen JPEG, O, and then you say what you want the picture to be called, JPG, and basically what this will do, unrecognized option, of course. I am an MCSE trying to code. Anyway, so basically this will take a picture. Again, it takes about that 5-second mark. And then what we can do is we'll go to whatever directory you're in and picture. So that's the picture that it took. So if you just want to verify before you get into the Python code, you just want to verify the damn camera works properly, those are two of the commands you can deal with to make that work. And that's the basic idea of the camera before we get into the actual Python and coding projects. Any questions?
Is there a way to speed up?
You might be able to go in, again, you can do a Google search. That is about the default. That's the default speed, so you can try to figure it out. Yep. With almost all of this stuff, there generally is a way to speed things up, but again, that's all.
And what was the website you have told me with which you can buy those cameras?
ARDUCAM, A-R-D-U CAM.
More sensors, more
All right. So let's start looking at labs. So everybody, Pi camera. Okay. So now if we go to page 8, we finally actually start getting into some code. So basically with this, once you have your camera connected to your Raspberry Pi, and you make sure it's working properly, you can write this very basic Python code in order to trigger the command from Python. And so this is how you'll actually take a picture. So I'm going to be using the OS module here. There is something called the subprocess module that is more secure, but it's also a little bit more complicated. That's why we're using the OS module here. So basically, if you're looking at this Python code, all this is going to be is we're going to import the OS module. We're going to create an image name, so whatever we want this picture to be called, so picture.jpg, and then we're going to create the command. So this is called an F string, so we're going to concatenate the image name with the command. So we do RPI cam -JPEG -output, whatever the image name is, and then basically os.system, we're going to then run that command. This is how from Python we can actually trigger a picture to be taken. So I'm in VNV, so we do Python 3 pi camera.py smile. Takes that amount of time, and then we go, and we can see our picture. Should have been updated. And so basically, this is a simple way that you can start taking a picture from your Raspberry Pi camera. And then once you have that, then you can start doing stuff with AI. The first project here, we're not going to do because it takes about 5 minutes. Again, we start talking about things like architecture. This is an important concept, is what is the response time? So Lava, again, we're on page 8 here. So Lava is the vision model that you can run with Ollama that will actually be able to take an image and it will be able to process, and you can ask it questions, right? What is in the image? What should the tags be in the image? Is this thing in the image? Blase, blase, blase. So it can do all that, and it can run all of that locally. Again, the issue is it takes 4 to 5 minutes to actually run that locally. So we're not going to do that here because I don't want to dance for 5 minutes while we do that. When we take a look at it, though, camera Lava Pi. Basically, when we look at this code.
So does it take like 5 minutes for each run?
Yep. Yeah, for every response, it takes about 5 minutes. Yep. And that's one of the things you need to be thinking about. Again, when we start thinking about the architecture and the systems, like, so if you're doing this as a real-time surveillance system, 5 minutes obviously is way too damn long. But on the other hand, like, what if you just need a number of images to be processed throughout the day? Remember, 5 minutes per image, equals 12 images per hour, equals 120, 240, like 300 images per day. So depending on what's going on, if you don't need real time, like if you know you're going to have less than 300 images in a day, you might just have it simply process as it goes. Again, it's kind of one of those things to think about.
What is like the bottleneck in this case?
Oh, the processor. I mean, it's a 1.8 gigahertz processor, and the GPU is garbage. Yeah. So basically with this is how you'd run it off of Lava. So you import Ollama, you import base64. So you're actually going to like upload your image into your own computer, and you import the OS module. So here we're going to say image equals pic. So the first thing that we're going to do is we're going to have a function for picture. And if we take a look at this, basically this is the same command that we did before. And the only thing we're doing here is we're going to be returning what that image name is. So this is where you could have a system for coming up with image names, maybe again with timestamps or something like that. So this is the image name for this particular timestamp, and then you're going to process it if you're going to have multiple images. If you do this particular code right here, do realize every time this script runs, it will overwrite this picture. So something to keep in mind. Basically then, what's going to happen is we're then going to take that image name and we're going to send it up to AI. So this is going to be going through Ollama and that Lava model. And essentially this is all basically just, it's essentially just copy and paste right here stuff. So what you're going to do here, this is a little function for encoding the image with base64. So define encode image, what the image path is. You're going to open it in a bit value, a binary value, and then you're going to return the base64 value. So basically what you have here is you have the encode image function, you give it the image name, and so this is going to encode that image in base64. You then basically come here with that value, use the model Lava, you basically ask it a question. So this right here is your prompt. So with this, describe people in this image. You can put whatever prompt you want, and then you're going to feed it that base64 value. And then down here is where you're going to get that response. So you're going to get that response back. And so at index content, so you're going to get response, message, content. This is simply going to be what the text is. This value is going to come back as response down here, and then we're going to print out response. Again, I'm not actually going to show you this work because it takes 5 minutes to run. You basically understand. So we've already had classes on Ollama. We've been talking a lot about Ollama in these classes up until this point. Is anybody confused that hasn't been in those classes? Anybody confused at all? Okay, so that's basically how Lava works. Again, that takes a long time. Yep.
So in order to run this one, so only the camera is required, or anything else apart from that?
Nope. So basically with this, it takes a picture with a camera, so you don't need anything else, just the camera itself. Yep.
If there's a typo, if that's referring to like the object you just created, it should be messages. Response messages, I think is the name.
Response messages? What? Message?
Yeah.
No, that's-
Go up a little higher.
Oh no, so response, so messages here is different. So message is here is,
Creating a new object. I see.
yeah. And again, with all this, if you're like, why do you do that? Copy paste. This literally just comes from Olama. That's why do you do that? Because Olama tells you to do that. So yeah, so this is what gets fed to this Olama chat function. This is part of the response from the function. Yep.
I might have missed it, but like on Windows, I had to have Olama running
Yep.
to use any of this.
Yeah.
Is that the same case in Raspberry Pi as well?
So once you install it, it should start with startup. I haven't had any issues. Once I install Olama, the first time I'll run Olama for anything, or one of these codes for anything, it takes like a minute to run, but then after that, it's fine. So I think in Raspberry Pi, it auto starts for you. So yeah, if you do get an error like, yeah. Oh, well, we'll close them a little bit. He said this place gets hot at night. Yeah. We'll close a little bit. Oh. There we go. We'll see how this goes. We're going to hear improv.
I have a question on like power supply. Like, say this is running for 5 minutes, and like the power supply is like jittery, or I don't know. But like, what? It just the OS would restart. There's not really anything that's gonna.
Well, basically, I mean, if it's jittery enough to trip the OS, it'll restart. If it's not, it's kind of like, you know, when you're running your computer and you have a little bit of a gray out, and sometimes your computer crashes and sometimes it keeps going.
Yeah.
I mean, that's basically the same thing, yeah.
So it could like be just jittery, like in the response itself, kind of performance without.
Yeah.
That's how bad the trip is.
Yeah, it depends on how, I mean, like if you're running this off of, like if you're truly running this off of solar, maybe you're gonna have an issue. I mean, as long as you buy the normal power supply, I mean, these are pretty robust power supplies, so you shouldn't have an issue with the power. Okay, so let's go to OpenAI to show you how the OpenAI works. So basically with OpenAI, what this is going to do is instead of running locally, where it's going to take 4 minutes to run, this is going to send the image up to OpenAI and they're going to get the response back. And this should take about 10 seconds. What is my code? So I do Python 3, camera, Python, OpenAI.py. Yep, so if I run this now, so it's going to take a nice little picture. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi, 9 Mississippi, 10 Mississippi, 11 Mississippi, 12 Mississippi, 13 Mississippi, 14 Mississippi. There we go. Okay. So the cool part about this is it completely offloads this processing up onto their $1 trillion infrastructure system. So if you take a look at this, again, it actually comes back with a lot. This image shows a classroom or seminar setting with several people seated at desks. Here's a general description of the people. Most are men of varying ages sitting at a desk and facing towards the camera. At least 2 people in the front row have laptops open and appear to be ready to take things. The person on the far left front has glasses and short dark hair, wearing a patterned shirt, blase, blase, blase. So basically, this was able to be taken from this little thing, sent up, and all of this information is able to come back to you.
So the 12 seconds was just because it went to OpenAI and waiting for the response.
No, actually going to OpenAI and back is relatively, well, as long as you've got a decent internet connection, at least a decent internet. Yeah, most of the time it's actually on their side. So again, depending on how complicated the image is. So if you have a pretty simple image, it'll probably come back a lot faster. So yeah, it's a lot of it's their processing.
What kind of internet connection are you on?
Whatever, fiber.
Wi-Fi?
Well, yeah, but they've got a fiber. They've got like 100 gig connection or whatever to this place.
Hardware-wise.
Oh yeah, so like I say, this is a 5, so it's a 802.11ac. So I mean, we're on, again, whatever their Wi-Fi here, so it's fast. Yeah.
So it looks like the processing took some time.
Yeah.
Take the image,
Yep.
parse it, and then send it to the OpenAI.
Yep. Yeah, so that's going to be probably about 10 seconds. 10 seconds of whatever that was them processing, and then 2 seconds were probably either side for the communication. Yeah.
You said you're using like the free API key?
No, this is not the free API key. This is OpenAI. So the Google Voice is a free API. This is using OpenAI, and this is the one you actually have to pay for. Again, you put $10 into the account, it'll last you like 3 years, but yeah, you do have to pay for it.
I was going to say, like, how many like, requests are you limited to per hour, or is it like tokens?
Yeah, so it's tokens. So again, you can look at your usage or whatever. Here, let's see if it'll tell me.
So how many tokens does like the image use?
That's where. Hold on one second. So let's see, dashboard. So you come on. Oh, bite me. Yes, connected. Okay, so we got here. We can come down here to usage. January 7th. Yeah, that's probably my first request today. So I don't know. I've used a penny this month. So yeah, I put more money in like literally yesterday, and so since yesterday I've used about 15,000 tokens, and that's come out to about a penny. So when you're using OpenAI, so we did have an OpenAI class, we'll have that again in the future. Most OpenAI stuff is dirt cheap. So again, you can see since December I spent 8 cents, right? Most of it. Where it goes off the rails is if you start using DALL-E. So DALL-E is the image creation software. That costs you at least 4 cents every time you run it. And their default code gives you back 3 images at a time. So it costs you 12 cents every time you run their default code. So that is the only service they offer where you could get into trouble very quickly, just as a normal lab environment. Most of the rest of the stuff is dirt cheap. I think it's like $1.50 per million tokens now. And so when you think about a token, like you're just doing text, 1,000 tokens is 750 words. So it's $1.50 for 750,000 words to process. And so again, with the images, wherever that comes in, it's not going to cost you a lot.
Just one last question. Do you know about like how many tokens or cents like that image request costs?
File cert images. I don't know. Images, response and chat completions. Yeah, so it's the 7th, right? Yeah, that might be the first one I did today. Yeah, I don't know. I mean,
I guess there's a way you can track that in your dashboard.
well, that's the 5th. Yeah, I don't know. I mean, unless it refreshes. It's pretty accurate. It's pretty up to date. So, yeah, I mean, I think that, yeah, it's less than, whatever the hell it is, it was less than a penny. Yeah, so it's, like I say, it's like, so again, you can see this is January 7th. So these are all the requests that I've done for today. And so, again, it's whatever I've done today is less than a penny. So, yeah.
Is the OpenAI preference, or does it have something advantageous different than Gemini or Wacom?
Like legacy.
For this kind of summer.
Yeah, I mean, basically, for me, like doing education, again, I believe in standardization. Like when I have my own business, everything just gets standardized. And so we've just been using OpenAI for like 4 years. And there's no real, for an educational point of view, there's no reason to get off of it. So again, if you want to use Gemini, maybe it's better. Who knows? Yeah. Yep. Okay, so that's OpenAI. We go and we take a look at the code. Basically, it's going to be the same thing, right? We have image equals picture, so we're going to take the picture. Now, we're going to use the AI function for OpenAI. And this is where we talk about this concept of SOA, or service-oriented architecture. The idea with service-oriented architecture is basically you can rip out one person's service and replace it with somebody else's. So basically, as long as you know a little bit of code, you can take my project here, and if you know what you need for Gemini, you can just paste in the Gemini code just to this one function and keep everything else, right? And that's the thing. So with here, all we're doing is we're ripping out the Lava code and we're putting in the OpenAI code. Basically with this, again here, if you haven't been in the class before, just to keep education easy, this is where you can plug in your API key. When you're using OpenAI, your API key should be an environment variable. That requires about 5 additional lines of code, so I normally skip it in these classes, but if you know what that means, you should do it. Anyways, this is where your API key goes. This is where you feed it into the client. You're going to encode the image like you did with Lava. The difference is now you're going to send this up to OpenAI. Basically what you have here, again, for the input text, so describe people in this image like you did before, and then you're going to feed it the image. When you come down here, the curious thing with OpenAI, and again, this is where different things are different. So with OpenAI, it's going to return a class value. So before, we use the square brackets in order to get to the index. With OpenAI, it returns a class. And so with a class, you do response dot output underscore text, and that gives you just the text that you're looking for. And that's what then gets printed out to the screen. So that's basically what we're talking about with OpenAI and the camera. Any questions? No questions. Cool. Okay, then the question is, okay, again, as it's come up, so you have your API key here. So every time you process an image, it's going to cost you a fraction of a cent. Who cares? Well, until you put that into a while true loop and you run it 24/7 for 365. All of a sudden, a fraction of a cent times that starts ending up costing a lot of money. So again, one of the things you need to be thinking about when you think about these architecture systems is how can you reduce your resource consumption to the absolute minimum value, right? You need to spend money, right? Your boss is gonna spend money. Give me the credit card, but we're not gonna try to not spend too much money. So the cool part with these Raspberry Pis, again, with these GPIO pins, is we can add a motion sensor. So basically with the next code, what happens is when the motion sensor detects motion, it will then take a picture and then send that picture to be processed. So instead of 1,000 images being processed an hour, you may have 5 images processed per hour. So basically with this, we are going to, if we take a look at the code with the PIR, basically what we're doing here now is we're doing from GPIO 0, import motion sensor. PIR is going to equal motion sensor at that GPIO pin 21. So again, when we're looking at this, 21 is not that pin. 21 is, I don't know, some other pin on here. Where? Is it down there? Yes, it's all the way down there. So GPIO pin 21. So board pin 40 is GPIO pin 21. Anyways, so basically what happens is we have the exact same thing as before. The difference here is we're going to have while true loop, right? So we're going to have a while true loop. So again, be careful with the while true loop. A while true loop means we're going to start this loop and it is going to continue forever. If you fuck up this loop, your credit card is going to get reamed. So be careful, I'm just telling you. Basically, this is the code here. So PIR.when motion, so when it detects motion, it's going to equal the process function. And so here, basically everything else above this is the exact same code we had before, only we put all of this processing into its own function now. So basically whenever there's motion, it will then trigger this function. We're going to take the image, we're going to send the image up, and then we're going to get a response. So if I run this code.
What's preventing that from like taking like 15 pictures in 30 seconds? Is there anything?
Because it's only triggered when there's motion. So I'll show you this. Boop.
I guess the question is, what if it's something happening?
Like what if I'm dancing in front of
Until
it?
you can't, right?
It will. So you could put a time. You could put a time on it. So again, with a timestamp, you could put start time and then like wait if it hasn't been so long, then it's like wait at least 5 minutes before you take another picture. So again, that's something that you could do.
So you can decide how many frames per second you want to take.
So with this, again with the PIR, so I'm going to do this. See, and I'm still, and I'm still, and I'm still. Oh, I moved. Now I take a picture of you. All right. Because I got the sensor looking at me. So see, now it's doing that, and now it's taking. So this will take a second, right? All right, now I got the da-da-da. Come on, OpenAI should be faster than this. Okay, so then it says that. Okay, so we're still. Oh, took a picture of you guys. All right, because it's actually pointing here. Anyways, so that's basically a thing. So every time I'm still, da-da-da-da-da. All right, so you got the picture. Oh, yeah, right. So anyways, every time that triggers, it's taking a picture. So again, it's a way to try to slow that down. Again, if you want to make this slower, you can use that timestamp. You can run, only take a picture every 60 seconds, something like that. Anyways, Control C, stop. There we go. Okay, any questions to the PIR sensor? Yep.
Without running like a web app or something, is there a way to input or get the amount of tokens you still have left? At least, have you ever tried it?
You can get, again, when this response comes, so this is a response, it's a class. Actually, here, I'll show you. Oh, no, it's on that damn thing. That's too much of a pain in the ass. Anyways, so when this comes back, so one of the variables in this response class is output text. One of the variables is in the amount of tokens that were used. So it'll tell you the amount of tokens that have been used, and then you can count those up. Let's say if you have a database as a record store, you can keep a tally of what's been used, and if you know what's in your account, then you can kind of figure out what's going on. It won't tell you how much you have left, though.
Yeah, but that is a way to keep track of it, though.
Yeah.
Hard-coded, though.
Yeah.
So
Yeah.
those are output tokens, but does it also keep track of the input tokens?
Yeah, it takes, it's the input tokens, the output tokens, the total tokens. So if you actually take a look at like I say, I've got to take it from there to there. It's all a big mess. But yeah, so it'll tell you the input tokens, the output tokens, and the total tokens used. Yep.
So updating the code you're saying is a big mess? Like, that's pretty...
Well, because the issue, because it's a class. So see here, I don't want to give you my API key. So the API key isn't the environment variable. So if I simply FTP this over here, then the API key isn't there. And so it just becomes a bit of a mess, yeah. Yeah. And then we can go here and we can see, look, utilization. After some more utilization, let's see, what do they give us? Ooh, we used 2 pennies. There we go. So now it says the 8th. So anyways, so in, I don't know, 4 or 5, so you probably get a few images per penny, if you're thinking about that from a budget standpoint. Okay, any more questions on that? No, cool. Okay, let's go to the I2C screen.
I have a computer vision model.
What's that?
I have a computer vision model.
Yep.
In this case, I'm connected to the GPT-4.
Yep.
It's pulling the data
Yep.
and providing it. It's more of a, the output is more of a text or something like
Yep.
that, right? If I have some computer vision models, in that case, will I still use a API, or I should load the model here just like what I do with Ollama?
Well, again, if you run Lava, so you can run Lava on here. So Lava is a vision model, but it takes 4 minutes to run.
Okay, I can install it here and run.
Yeah, and that's like I say, the first code here, if you look at the code on whatever it is, page 8, where it says PyCamera Lava, that will run locally. It just takes 5 minutes to run. So, and that's the thing too, when you're thinking about the models and what do you want the output to be. So again, before I killed my precious little pet earlier tonight, this thing is a Pi 4, so not a Pi 5. It runs OpenCV locally with a face detection model on it, and it runs fast enough for this little robot to work. So if all you're doing is faces, or all you're doing is like license plates, and you use the right model, it can run very quickly. There's a model called YOLO, so it's trained on about 500 different types of objects. It will also run relatively quickly, even on these low-power devices. The thing is, with Lava, with what's called Moondream, with these other vision models, they're just so big that, again, they take minutes to process. So like with this, like with OpenCV, it is literally running against a video stream. So you'll get a 15 frames per second video stream, and it's literally running fast enough to run on a video stream. Whereas that's 5 minutes per request. So, yeah.
I mean, I guess it sounds like it is feasible to make it almost fully autonomous.
What's it? Yeah.
If you have it locally, you don't care about duration, take a picture in 5-10 minutes, put it on wheels, goes around,
Yeah.
power it with a solar panel that feeds battery.
Yeah.
So you can make it autonomous pretty much.
Well, and that's the thing, like I say, when you think about architecture, is again, when you're designing this stuff, like this is going off to OpenAI right now.
Yeah.
Let's say you don't want to go to OpenAI, you don't want to pay OpenAI. You could have a server, and again, when we talk about server, you can just have a better machine running on your local network, and you could have this little Raspberry Pi sending the image to a local machine, and it could process it in 2 seconds and then send the response back. Right? Again, that's when we talk about architecture. How do we design the overall platform for what we're going for? Yeah.
You could also do something like you send the initial image just to ChatGPT to make sure.
Yeah.
As you're waiting those 5 minutes, you turn on OpenCV and use that for the rest of the time, like to do like tracking or something.
Maybe. I don't know. It starts getting a little complicated. It's like that sounds like a great project for you. That's extra
Is it easy to,
credit.
like switch back and forth between like if you're running say like OpenCV, the API, and like Lava, or is it common you only want like one?
Well, so depending on so only one process can use the camera at a time. So one of the interesting things with the Raspberry Pi, you only have one camera connection on here. Curiously enough, with a Raspberry Pi 5, they actually give you 2 camera connections. So theoretically, God help you writing the code, you could have one camera going to OpenCV and another camera going to Lava. Or, I mean, you've got, four USB ports on here. So you could have 2 cameras connected and 4 USB cameras. I don't know what the hell resolution you could run it at, but theoretically you could have 6 cameras all going to different scripts. Again, at some point it's going to crash and burn, but yeah, so technically, yeah. Yeah. Again, that's the kind of thing where like if you're doing kind of like that vision stuff, that's where you'll get a mini PC. So like at home, I have a full-fledged robot you can do a lot of cool stuff with. And I have a AMD micro PC. It cost me $900 for this thing. So it has a real GPU on it. It has a real processor. It's 32 gigs of RAM. So if I wanted to connect 5 cameras to that thing and have them all doing different stuff, I would feel very comfortable doing it. That, I don't know, have fun. Yeah. Yep.
Yeah, not to get into the weeds, but I'm just curious if your local models, can you like dedicate cores for it to use on the Raspberry Pi, or does it have to use like all 4? If you wanted to do some kind of parallel.
So with this, I'm using Ollama. So Ollama is just one of these model frameworks you can use. So with that, as far as I know, you can't. If you actually go into Transformers, so there's something called Transformers. So you can, if you use something called PyTorch, PyTorch is the actual AI framework for running this stuff with a lot more sophistication. You might be able to do that in PyTorch. But again, it's a potato. Like,
How much do you know about?
exactly. It's like you got like a really fancy Xeon server, by all means play with it, but it's like you're going to dedicate cores on that. I mean, yeah, I don't know. You can maybe, I don't know. Yeah. Yeah.
Oh, to the point of the previous question, why wouldn't you just save the image in memory and then send it to different AI models instead of having 2 cameras? You can just save it locally and then...
I mean, it basically depends on how you're going to be designing, I think. So again, like when you're using OpenCV, if you use OpenCV essentially, when you're looking at the video feed, it's actual individual images. It can be saved as a frame. So theoretically, you could take that frame and then you could send. I mean, again, I don't know, have fun. Yeah. Again, like that's one of the things. Like trying to show you folks how all this stuff is I think there's this idea with programming, like there's one way to do this stuff, and there really isn't. Like I think I honestly believe that would work. So you might want to do that. I just don't. Yeah, basically. Yeah, it's just like I don't know what the conflicts are got, like what conflicts there's going to be there. I don't, so that's where again you can play with it. Yeah. Again, it's a potato. It's just yeah. Okay. Any other questions with this? Yeah.
One question. So I'm kind of familiar with so RAM is the bottleneck for how big of a, let's say a large language model you can fit onto the thing.
Yep.
Now, when it comes to the speed, the latency of the decision.
Yep.
You were saying that one of those was the 1.8 gigahertz. So
Yep.
that's 1.8 billion. Operation per second, right?
I guess so. Yep.
Yeah. So what? And then that one was taking 4 minutes. You said.
Yeah.
Is there a general rule of thumb? Okay, how many? I guess gigahertz or how many operations per second do you need to make it to operate some of these models, to make it let's say if you wanted 1 second as your requirement, is there a way to calculate that?
I think there would be if you're using actual NVIDIA GPUs, if you're using a real computer. Again, for love of God, guys, this is a fucking potato. I don't know how to it's a little potato. You're doing a good job. It's a fucking potato, people. Yeah. So yeah, if you start getting into the real AI world using actual NVIDIA GPUs, I have no doubt you can find that particular calculation. For this thing, again, it's using a 2 billion parameter model, so you're not going to get that much smaller, I guess a Lava model is bigger, but you're not going to get that much smaller of a model on this thing, so you're just going to get this level of performance,
So
yeah.
you said that was 8 gigabyte RAM?
Yeah, so this has 8 gigs of RAM. Yeah.
So that fits a 2 billion model?
Yeah.
Parameter.
Yeah. So basically, that's the thing, is when you're talking about AI, any of these LLM, these model tasks, basically what you want are GPUs. GPUs are graphics processing units. They are specifically designed to do these AI tasks. CPUs many times can do the tasks. They're just very slow doing them. And so, yeah, it's a potato. It's a pretty potato, but you're a potato. Okay, let's talk about the I2C screen. So one of the cool things when you start talking about Raspberry Pis is you can add screens. So I showed you folks, you guys had the screen around before. And so again, this is an I2C screen. And so one of the big things to be thinking about, when you talk about computers nowadays, one of the things that frustrates me is everybody's worried about ray tracing, 8K, 240 hertz per second ray tracing. And they're I just need to know its IP address. I don't need anything else, right? And that's going to be one of the important things. With a lot of these devices, one of the things to consider, again, when we start talking about designing things, what do you actually need? Do you need 240 hertz? Do you need 8K? Or again, do you just need to know what the hell the damn IP address is so you can get into it? And so that's one of the cool things with this. So this is a 20 by 4 screen. So it's 20 columns by 4 rows. And basically this can print out information for you. Again, this uses I2C, so you need to install the I2C tools to make sure this thing works, and you need to run the Raspi config little application to make sure your I2C thing is on. You also need to install the modules, RP LCD, that's for the LCD screen, and something called SM bus. When you look at wiring here, I don't really give you a good wiring diagram, but basically you need the 5 volt to go to the VCC connection. You need ground to go to ground. SDA, if you look at the back of this thing, if one of you guys have it, you'll see SDA back here. So SDA goes to the SDA pin I showed you before, and SCL goes to the SCL pin. Basically, you connect all those up, and hopefully you should have a screen. The backlight, if you don't have a backlight, you'll see the jumper. There's a jumper, no backlight, jumper backlight. Woo! That's your fanciness there. Right? If we go and we basically take a look at this, we can do the hello world script. And we do hello world. So we are on page 11, LCD Pi. And so, ooh, look at that. See, hello world, Raspberry Pi. So basically all you're doing is you're printing out to the screen itself. And again, you can put all kinds of different information there. When we take a look at the script, again, it's very simple. So again, from RP LCD, I2C, import LCD, from time, import sleep. This is where we're going to configure this. So char LCD. This is actually the pack on the back of this thing. So again, this is the I2C module. And so basically, that number should be fine for you. If this doesn't work for some reason, you might need to Google search what's wrong with that number. And then we come to this address. So remember when you folks saw 27? So basically 0x27, so this is the address. Port 1, so we do columns 20. So columns 20, rows 4. The next thing you do here is LCD clear the screen. So this is one of those weird things. If you don't clear the screen won't be cleared. So if you're writing things on the screen and you don't clear the screen, you're just literally overwriting everything you wrote before, and at some point it turns into a black blob. So if you're like, why is there a black blob? It's because you're not clearing the screen. So all we do here is we can simply do lcd.writeString, hello world from the Raspberry Pi, and that shows that up on the screen. We just sleep for 10 seconds, so it stands there, it's there, and then we clear the screen. So that's basically just a very simple way that we can print something to the screen. So again, we could print back, if we're looking for things from images, if we're talking to it, that type of deal. Is there any questions with that?
So like that sleep function, would that work on one of the other ones that doesn't have the real-time clock, or that's just?
Yeah. So the sleep function is just a sleep for seconds. So it's not a timestamp. It's just from now, sleep for 10 seconds. Yeah. So yeah, with that PIR thing where you're saying like if you don't want, so you could you could do sleep and you could say sleep for 30 seconds. So it wouldn't take another image for at least 30 seconds.
I guess that's like more about the outside time, the real-time controller.
Yeah. So the real-time clock, basically you set it up to be consistent with time. So the idea, if I have images that are time-stamped on this thing, they will be at least relatively similar to what my other server's timestamps are. So if I go and I say, oh, I need to see what image was taken at 8 o'clock at night. Now, again, it might be a little off because it's a fucking Raspberry Pi, but you could go to it and go, oh, yeah, okay, right around 8 o'clock at night, these are the images that were taken.
But if we use like anything like smaller than like 5, like 4 or 3, we won't get the timestamp for the image?
With the... No, because so this has the real-time clock installed. So basically, as long as you put the little battery pack on it, once you set the real-time clock, that real-time clock will continuously run for the next 20 years. So theoretically, if you have this thing connected to the internet, so again, it would need to be connected to the internet, if it updates using the network time protocol, so as soon as it updates using the network time protocol, then it would have the current timestamp. But it would have to be able to connect to the network and connect to that network time protocol in order to get that new timestamp. So again, this is built in, that's kind of duct taped on.
So it uses like Wi-Fi to get that?
Yeah, Wi-Fi, or again, it's got a network cable on it. So basically, however it's connected to the network, yeah. Cool. So again, to use something a little bit more useful with this, if we go to Pi LED IP, again, doesn't seem useful until it is. Basically, if I run this, I hit enter. So what this is going to show us is this is dynamically going to show me my loopback address, 127.0.0.1, and it's going to show me my actual IP address. Well, darn it. Come back here. Enter. 10.255.2.250. I definitely not would have guessed that. And it gives me my slash, so /16. So basically that can print up here and again give you the thing like the IP address. Basically for this, again, we're not really doing a lot of AI with this particular code. Essentially what comes here, let's see here, is we're going to do a command. So this command, we're going to send this to the OS module. So IP address gives you all your IP addresses. So we're going to grep for iNet. So that's going to give you your IP. It's going to give you your IPv4 and your IPv6 addresses. We don't want IPv6, so we're going to grep basically negative /v for not iNet6. And so what's going to come out here is it's only going to give me my IP4 addresses. We're going to clear. And then basically what's going to happen down here is So when the command comes back, each line is going to be a value in a list. So read lines turns each line into a value in a list. So we're going to have 127, the line that has 127.0.0.1, and we're going to have the line that has that 10.255.252, whatever else. I'm going to print that out on the screen. So basically that's where we do this, and we print this out on the screen. So these are the two lines that are going to come back to me. See iNet 127.0.0.1 and iNet 10.255.2.250.16. Those are the two addresses. All right, so basically we're going to come down here, for text and response. So these are the two. Line equals, we're going to split the line where there's a space. So basically we're going to go to each line, and wherever there's a space, we're going to turn that into an index value. And then basically we're going to say for value in line, so the value that comes back, if there's a slash, so basically if there's a slash, we're going to do LCD cursor position, row 0, and then whatever the value is. So basically we're going to keep incrementing the row. So row is 0 here. So at row 0, column 0, it's going to print the first value. And then it's going to iterate one up. So it'll be at row 1, column 0, it'll print the next value. And that's how, if you have like 4 or 5 different IP addresses, it will start printing all of those basically down the screen. It's a very janky way to get it done, but it does its job in a couple lines of code. Any questions on that? This is the kind of stuff, so again, we're having that introduction to Python, that full day introduction to Python course coming up on the 17th. That's where we're going to get into this whole split and lists and value and iterate through type stuff if you don't understand.
So this LCD, I guess,
Yep.
if you want to code LED, it's a little package you have to import. And the reason I ask that is because the file name on the computer says pi-led, so I assume it's like a typo.
Pied.
You typed LCD on page 12.
Oh, yeah. LCD. Oh, yeah, that's just a typo then, right? I'm doing LCD, right? Yeah, that's just a typo. It's just a typo.
So I'm assuming, I guess my question is, it would, I guess, cost more if you're trying to do something with LED.
What's that?
If you want to use a LED, or say like a scoreboard.
Yeah.
It's almost the same logic. It's the same flow.
Yeah, it's the same logic. You would just do it differently. So like this is actually a very fancy OLED screen. So you can say, oh, I got an OLED screen. I'm so cool. Anyways, yeah, this uses zone map. What's really cool about this actually is you can do shapes. So you can do shapes. You can actually do I mean, it's that big, but you can do animations. You can do a lot of stuff with it. But yeah, it's going to require its own mess of how you get that to work. So like, yeah, so you could have like a really big LED. Again, like Adafruit actually sells pretty large LED display boards. And so, yeah, the same logic can be used. The actual code that you're going to be write is whatever Adafruit tells you to do. Yeah. Okay. Any other questions? Okay, cool. Let's get to text-to-speech then with PyTTSX3, and we're on page 13. So again, the big thing when we're dealing with this is you are going to make sure to install the Pipewire-ALSA application onto your Raspberry Pi. You do not need that if you're using Mac or Windows or Ubuntu on a normal computer. Again, this is only if you're using this particular potato. The cool thing is with this is, again, with eSpeak, so you actually, if you look at it, you do sudo apt install eSpeak libspeak1 and eSpeak-ng. And the cool thing with eSpeak is that this is just a command line tool. So if I type in eSpeak, hello class.
Hello class.
Right? So this is completely synthesized on the machine itself. It's not going anywhere. And the great part about this is this requires no resources. You can run this thing on a Raspberry Pi Zero and it works perfectly fine. You're not going to get a lot out of it. With eSpeak, with all of this, you can change some of the accents to a degree. You can change the speed. So if you don't change the speed, sometimes it'll talk really, really quickly. You can change a few little things, but not a lot. The value, though, is that it works on almost anything. If we take a look at the pytts.py script, So TTS is text to speech. .py.
Hello, world.
And that's basically coming from the Python script itself. If we take a look at the Python script, where is it? TTS. This is all the Python script is. And again, it's incredibly easy to use. This is the one thing I talk about. Again, AI is hard. AI is really hard. APIs are not. I think this is one of the things a lot of people get confused about in the modern world. They're like, oh my golly, Eli, I'm not as smart as those people. Like, no, you're not. No, don't worry, you're not. But you don't have to be. Right? Again, you get all of this power with 5 lines of code. APIs are easy. Again, and so you look at this. Basically, you just import this module. So you do engine equals. You're going to initialize the module. You put in the text, whatever you want the text to be. And then engine.say, whatever that text is. And you do engine.run and wait. Again, I don't know why they do this, but this is how it's written. So this is when it actually runs this. And that's where you get the hello world. And so that's all the code you need to get your computer talking to you. Any questions on that?
And is the audio like coming from the Raspberry Pi or?
Yeah, so when I run this, it's...
Is that an extension? Okay, yeah, that's
Hello, world.
Yeah, so it's just this thing. Yep. So yeah, you could run it off this USB thing, wherever all my cards and stuff are there, that speaker hat. Yeah, you could... so this is actually a speaker hat, so if you configure the speaker hat properly, you can have it running out of the speaker hat. Yeah, whatever. If you have Bluetooth connected to it, so you could have this on a big Bluetooth, stereo system. Hello, world. Yeah. Okay, let's go over to page 14 then, for speech recognition. So basically with speech recognition, there's 2 ways to do it on a Raspberry Pi. One is using the Whisper module, and the other is using Google. For both of these, you're going to use speech recognition. So speech recognition is kind of the default everybody goes to for Python that allows you to run speech recognition on your little potato or whatever else. Basically, within the speech recognition module, there are a lot of different options for different services that you can use. Right? So if we look at the Pi Whisper, basically what this is going to do is it's going to detect locally. So if I do Pi... So what's cool about this is running entirely locally, does not go out. How much chuck could a woodchuck chuck if a woodchuck could chuck wood? Come on, do me good, do me proud, do me proud. Sometimes you literally get Swahili. Come on. Yeah, so this is going to take a second. Again, it's local. It's a potato. There we go. Transcribing. How much check would check if woodchuck could check wood? Anyways, almost.
pretty good.
Pretty good. You are a very disappointing little potato. I expected more out of you. Oh, don't be mean to your potato. You are a very disappointing little potato. I expected more out of you. So again, if you're not trying to be a complete smartass with it, it is actually pretty accurate, right? And the cool part about this is running entirely locally. The issue is you are running entirely locally, so that takes a little bit of time, right? So if we use the Google STT, so Google.py. How much chuck could a woodchuck chuck if a woodchuck could chuck wood? So there we go. Recognition thinks you said how much chuck would a woodchuck chuck if a woodchuck could chuck wood. So one, it is a hell of a lot more accurate, even in a bizarre thing, and it's a hell of a lot faster. I am so proud of you, little potato. That's what I expected. There we go. I'm so proud of you, little potato. That's exactly what I expected. Yeah. So again, those are the things we have to be thinking about with architecture. You have Google, works incredibly fast. It's a hell of a lot more accurate, but it's going off to Google. Whereas with Whisper, less accurate, takes more time, but it's entirely local. If we take a look at the code, so Pi Whisper. Basically we have here, again, we're going to have that speech recognition. So you're going to import speech recognition as a sr.recognizer. This is a recognizer function, R. And so what you're doing here is just with microphone. So this is going to come in with microphone. It's going to print listening. It's going to take a second. It's going to adjust for ambient noise. So this is a function in there for the ambient noise that's around it. And then audio equals listen, and it's going to listen to what you say. It's going to print out transcribing, and then it's going to say, you said blah. If there's an exception with an unknown error, Whisper could not understand the audio. If there's actually a known error, could not request results from Whisper local service, and it's going to print out that error for you. But basically, this is all the code you need to actually get speech recognition working, again, locally on this system. If you do the Pi Google STT, basically it looks the same. Again, you're going to be bringing it in from the microphone. It's going to be listening. And then simply down here, again, this is all just copy and paste essentially. Google Speech Recognition thinks you said, and it's going to say what it thinks you said. And then if there's errors, it's going to give you those errors. Does that kind of make sense to everybody?
So this one, you basically triggered it manually to listen to you.
What's that?
The speech to text.
Yep.
Script, you triggered it manually
Yep.
to listen to you.
Yep.
And then transcribe it. But I guess if you wanted to do like a hey potato, then you just have to do a while. It stays all listening the whole time. You just do a while, whatever.
Okay, give us about 5 hours. We're going to get there in about 5 hours. We're getting close. We're getting there. That's the whole thing. So if you're new to my classes, what I always try to do is I try to build up. So I'm just showing you how this works, and we're going to keep adding on to the idea of how you're going to build these systems. So yes, we're going to get that in a little bit. It's almost 8 o'clock. Okay, we're going to deal with speech recognition and OLAMA. So basically with this, we have this code here. So Pi Talk OLAMA. And basically what's going to do here is we're going to have a while true loop, and then we're simply going to print out to an HTML page. So Python 3 Pi Talk OLAMA .py. How are you doing today? What we're going to do is we're going to go up here, and we're going to conversation. There we go. I'm function. Yeah. How much chuck could a woodchuck chuck if a woodchuck could chuck wood? Yeah, there we go. Yeah, and so this was the first project that I tried to get running on my little Raspberry Pi Zero with the ARM6 architecture, and modern web browsers don't even work on the thing. So a woodchuck could chuck about 3 to 4 pounds. Oh, then I arrowed out. Anyways, a good joke about 3 to 4 pounds. Anyways. Yeah, still. Yeah, there's no trigger on this, so it just keeps going. Let's see if it gives us a joke about it. A man walks into a cafe with a small dog. The waitress asks, "What's your dog's name?" He says, 3.5. She replies, "No, I mean his name." He laughs and says, "Well, he's 3 pounds 4 ounces, but we call him 3.5." So there, look, it gave you an actual. This is literally running locally on the system. So, anyways, if we take a look at this code.
Oh, that's running locally?
Yeah, this is all running locally. So this is that when I talk about the Granite 3 model, I'm telling you the Granite 3 2.2b model is actually really good. So we take a look at that code, and we're looking at page 16, Pi Talk Llama. Yep. So it's here. So again, we're going to import speech recognition, and then we're going to use OLAMA. We're going to import chat function and chat response, the normal OLAMA stuff. One of the interesting things here is with the speech recognizer, this is a good thing to use ChatGPT for, to ask the different options and configurations. So it was cutting me off. So you can change these little thresholds. So pause threshold of at least 1 second, phrase threshold of at least 0.3 seconds, non-speaking duration of 1 second. So I was having the problem of you say something and you pause for like half a second, and then it just takes that and processes it. It's like, oh. So anyways, by adding these additional thresholds, it allows you to listen to a little bit more normally, I suppose. And then we have this while true loop. So again, what he was talking about before. So while true, query equals STT. So we have the STT function, and that is simply that Google, I think we're using Google here, So this is Google. Yeah, Google Recognizer, basically what we had before. And so what's going to happen is message equals text. So the text that comes out, we are basically, we're going to, with open, we're going to write this to that HTML page. And we're going to have a auto refresh of every 5 seconds. So basically we write this to the page and we refresh every 5 seconds. And we're going to write the message that comes in. Basically what's going to happen down here is if query does not equal error, response is going to go to AI, so the AI function. The query is going to come up, answer in fewer than 20 words. So the query is going to be the injection. So the injection and the query. So answer in fewer than 20 words, what the query is. We're going to use the model, Granite 3.3, 2 billion parameter. The query is going to go in, and then we are going to get the response back. And basically what's going to then happen here is with open conversation.html, so that HTML document, append, so this is going to add to the end as F. We're going to write a line, and then we're going to write the response in. And so this is going to show us what we asked, line, and what the response is, and then it's going to refresh. Does all that kind of make sense? Cool. All right. Then, then we're going to go to text-to-speech. Basically what we're going to be adding here is it's going to start talking to us. Oh, stop. Control-C. So we're going to do a llama speech. How much chuck could a woodchuck chuck if a woodchuck could chuck wood?
How much chuck could a woodchuck chuck if a woodchuck could chuck wood? A woodchuck could chuck about 3-4 pounds of dirt when digging for burrows, not wood. The phrase is a tongue twister, not a factual statement.
How do you cook woodchucks?
How do you cook woodchucks? Woodchucks cannot be cooked as they are mammals, not suitable for human consumption. They are protected under the U.S. Animal Welfare Act.
So anyways, so this is now basically, again, we're adding things together, right? So we had the speech to text, and we had Olama, and now we're adding the text to speech back. And so again, one of the things with this too is you need to be thinking about, like, for the user, the user experience, especially since we're using AI. One of the problems is the response that you get back might be nonsensical. And there's two questions. Is the model crap? Again, are you using Pi 3, which might be crappy? Is the code crap? Or is it just simply not understanding you? So again, one of the things to think about with user interface and user experience is by having it repeat back to you what you asked it, you know from the get-go, at least it understood what you originally asked it. So anyways, if we take a look at this code here, it's all pretty simple. So page 18, Pi Talk Olama speech. And so basically it's the same kind of stuff here. Again, speech recognition SR. We got Olama chat response, and now we're importing PYTT SX3. We're setting the thresholds here. We're setting thresholds here, so hopefully it understands us a little better. And then for PYTT SX3, these are where we can set some properties. So for here, we're setting the voice for English, US. I don't know, it sounds a little British to me, to be honest with you. But anyways, so you can set a voice here. And then you can set the rate. So I set this to 170. So 170 is that. I think it's the lower the number you give it, the faster it'll be. So it starts to sound more and more like a chipmunk. So again, you have to, it's that weird kind of thing. You have to decide how fast this thing is going to talk. Basically, the code looks a lot the same as everything else. So while true, we're doing a continuous loop. Query equals speech to text, as we did before. We're going to print out that query on the screen, just so we know what the hell's going on. Then we're going to have this function, text to speech, and we're going to send it the query. So the thing that we said, and all that is this particular function here, and it simply says engine.say text, engine.run and await. So here what we're doing is so we talk to it, We're going to get that value back from Google, and that's going to go to query. Then we're going to take that value that we got back from Google, and then we're going to just kind of spit it back at you again to verify that it heard you properly. Response equals AI query, so that query then is going to go to AI. We're going to print the response back on the screen, and then simply that response is simply going to go, again, to the text-to-speech function that we created here. That's all this function is, and so it's now going to tell you what the response is.
Looking at the code, this one doesn't use the HTML file. Can you just explain again why you need the HTML in the PyTalk Llama?
So basically, you need an output somewhere. And so the issue is when you run PyAudio, depending on what you run PyAudio, if you run PyAudio directly on Ubuntu, works beautifully, no problems. When you run PyAudio on any other thing, it just gives you a mountain of errors that don't matter. So basically, I need a clean place to be able to put the query and the response so I can see it without all of PyAudio's errors. So like if we run this on Ubuntu, you can simply have it print out query, print out response, it all looks nice and clean. The problem is when you run this on Raspberry Pi or almost anything else, what's going to happen is you're going to print out the query, it's then going to give you just 5 pages of errors, and then it's going to print out the response, and it's very difficult to see. So the reason I was printing it out to the HTML file was just to give me a clean page where I can see both of those things. Yeah.
And then you use that HTML file to input into the AI.
No. So the HTML file is simply an output. So basically...
So what you're displaying is the HTML file on the terminal?
No. So that's the HTML file. Right. So basically what's happening with these is when I made the query, it got written to the HTML file, and then when the response came back, it got written to the HTML file. And then when the new query went in, the old file was erased, so the new query goes in, and so that's just getting written here.
Right.
That's a browser that's open though.
Yeah, this is a web browser.
Yeah, no,
I'm
I'm just a little confused why. What is it? So you don't really need the HTML file to get the response from the AI?
No, you don't need the HTML.
Put your response.
Yeah, so basically as we're building this up, so that was just showing you I could talk to the machine and get that response back, and then it's just showing me here. And so once I can prove that, now we're having it talk to us instead of printing out to a web browser.
But you could put it into a text file or something.
Yeah, you can print it to a text file, database. Yeah, it's just whatever it was. What's that? PyTalk Llama? Yeah, so basically with PyTalk Llama, right? So basically here, right? So with open conversation and we're writing. So yeah, you could add this as a value into a database. You could add this simply to a text file, whatever. Yeah.
Got it, yeah. I was just wondering if it needed to be like some kind of XML format or something to send to the AI or something like what it is.
Yeah, no. See, this is within the function itself. See, this is the speech to text file, so it's in the function itself. And then down here is we get the response back from the AI, and then we're going to write that response into the HTML document. Yeah. Any other questions? Cool. Okay, now we're going to get to the LED. So one of the big problems here is the whole question as we start talking to this machine now, right? So we get to talk to it, it's talking to us back, but one of the things you're going to notice is that there's lag, right? So we talk to it, it has to send our words somewhere, get the response back. It then goes to Ollama, it's going to take a few seconds to get that response back, and then it has to talk to us. So one of the things we don't want to do is we don't want to be talking to a computer while it's doing something else, right? You don't want to talk to a computer that's basically ignoring you. So that's where we come up with this whole little LED system down here. So what this LED system is going to do is it's going to show us where it is in the process. So when it's green, it means we're able to talk to it. It is paying attention to us. When it's blue, it means it's processing. And then when it's yellow, it means it's speaking to us. So if I run this code, speech LED, LED. Green. How much chuck could woodchuck chuck if a woodchuck could chuck wood?
How much chuck could a
So
woodchuck
there's the
chuck
blue.
if a woodchuck could chuck
So I
wood?
can talk to it now, and it's not going to matter because it's processed. It's not listening to me right now. So it's going through the whole processing thing.
A woodchuck could chuck about 3-4 pounds of dirt when digging for burrows, not wood. The phrase is a tongue twister, not a factual question.
That's a bad response because
That's the bad response because
What's that?
you're already including your same.
the answer is too brief and lacks detail for a comprehensive understanding.
Here, let me stop.
Yeah, I mean,
What's going on? What's that?
You're like clarifying already in the tongue twister that woodchucks can't chop wood, or you're saying if the woodchuck could chop wood. I'm just messing with the AI. I like to push it a little, you know.
I don't know. So it's, I don't know. Say something. What is the difference between a woodchuck and a groundhog?
What is the difference between a woodchuck and a groundhog?
And blue turns on.
A woodchuck is a type of rodent, specifically a burrowing marmot, while a groundhog is colloquially known as a woodchuck in North America. They are essentially the same species, Sigiridae genus.
Now the cool part in. Tell me a joke about Louis Rossmann.
Tell me a joke about Louis Rossmann.
See, now look at this. I do not need my pretty 4K screen to now talk to my AI project.
Why did Louis Rossmann's watches always be on time? Because he never lost his sense of timing.
Thank you. You're a very good potato.
Thank you, you're a very good potato. Thank you. I'm here to assist. Your message is unique and appreciated.
There you go. And so that's, again, that's one of the things we need to be, how do I
And
get,
so that again,
Oh,
that's one
stop.
of the things we need to be.
yeah, stop. You're not a very good potato. I don't like you anymore.
We must consider sustainability.
Stop. Anyways, so again, this is the, there we go. This is the kind of thing that we need to start thinking about with our AI systems, right? So much focus over the past 20 years is getting to 100-inch screens, well, again, 240 hertz and 8K, the whole 9 yards. One of the interesting things is once we start dealing with AI, we need to start building these interfaces that actually make sense to people. And the interface might literally only cost us 20 cents to be able to create. So with this code, basically it's pretty simple code here. If you go to page 19, so speech LED. So again, so with this, this is a breadboard. Again, breadboards cost you about $1. These are what are called jumper wires. I guess they're jumper wires. You can go get a set of them from Amazon for a couple of cents. LEDs, again, also for about $4 or $5. You can get like 100 of them. The one thing is make sure you put these resistors in there. So these 10,000 ohm resistors, I think they're 10,000 ohm resistors. Do a Google search on it. If you don't put these resistors in there, you'll burn out your LEDs. Like even though there's not very much power coming off of these GPIO pins, there is enough power to burn out your LEDs literally faster than you'll know. It won't be like a light bulb where it goes boom and you're like, oh, I blew it. It will simply not, it will blow before you even realize it blew. So you do need those little resistors in there when you're doing this. But anyways, when you do it, LED, let's see here, import request. Why did I import request? Do I know my own code sometimes? Oh, that's OpenAI. Was I doing OpenAI? No, I was doing Ollama. Sorry, let's see, Ollama. Ollama LED, there we go. So anyways, okay, so we got speech recognition. We have Ollamas we had before. We have PyTTSX3, and now we have GPIO 0. We're going to import LED. So basically, we're going to create our little LEDs. So we're going to have these variable values, LED ready, LED processing, LED answering. We're going to use the LED function. So we're going to set this to 17, 27, and 22. So that is board pin 11, board pin 13, and board pin 15. So anyways, so we're using those Broadcom numbers here. We have the speech recognizer, as we had before. We have the PYTTSX3 initiation, as we had before. So basically all this code is as we had before. The difference is now we're going to be turning LEDs on and off. So while true, so basically when this is ready, when it's ready for us to talk to it, LED ready is going to be on. So simply .on function is going to turn that pin on. We're going to do query, speech to text. It's going to go process. When that's done, LED ready is going to turn off. We're going to say if query does not equal error. Then we're going to say TTS, the query, so it's going to speak to us. Then we're going to do LED processing on. We're going to send that to the AI. Once it comes back from the AI, we're going to turn it off. Then we're going to do LED answering on. We're going to then text to speech the response. It's going to speak the response to us. And then we are going to turn the LED answering off. And then it's going to continuously loop. So when it's ready for us to talk to it, it's going to be green. When it's processing, it's going to be blue. And when it's talking to us, it's going to be yellow. And so it gives us an idea of what's going on here in the process. Pretty simple. Any questions there? Oh, cool. Okay, we've only got a few more pages to go. Oh, yeah, we got my extra credit. That died. Never mind. So that's the LED. Okay, so the final thing is the prompt, before we get to my dead car. And so again, basically what he was talking about before is the big issue is, right? What if we're not talking to it? I mean, right now, I want to talk to the class. I'm not talking to you, potato. See, it just blinks, right? I'm talking to my class. So we're going to sit here, we're going to have a nice class, we're going to have a nice conversation, and right now I'm not talking to the potato. Hey, potato, what time is it? Hey, potato, what time is it?
What time is it? 2017-32.
There you go. Nice. Hey, potato, tell me a joke about a cat and a dog.
Tell me a joke about a cat and a dog.
That's going to process. It's going to blue.
Why did the cat adopt a dog? Because it wanted a person friend.
All right, fair enough. Hey, potato, light on. Oops. Sorry. Hey, potato, light on.
Light on. Light turned on.
So we have a relay connected to it now. And now I can say, like, hey, potato, what time is it? Hey, potato, what time is it?
What time is it?
Right.
2018-15.
So it gives me that. Then, hey, potato, light off. Hey, potato, light off.
Light off. Light turned off.
Right? Yeah. So now, see, but notice, again, we start talking about artificial intelligence. Like every time you hear about artificial intelligence, all this big stuff. It's $1 trillion in infrastructure. Look at what we've been able to build with a potato in a couple of hours. Like, again, and basically what's happening here is this is what's called a relay. So this costs you $30. So I use this relay because it's very safe. You're probably not going to electrocute yourself with this. You can get relays for about $1 a piece that you might electrocute yourself with. They're not all nice and contained the way this particular one is. But basically, we have the GPIO pins connect to this relay. And so what happens here is I create that trigger phrase, the hey, blah, spud, right? That when it hears that, it then knows a command is coming, and then I have a series of functions, and all it's doing there is it's saying if these values are in the function, then fire off this particular function. And as he's taking a picture, I realize I need to take a picture, because if you don't take pictures, things haven't happened, and I keep forgetting to take pictures of full classes. There we go. I'll do a little class over there, and a class over there. Look, it's so big you had to take 2 pictures. Okay, so let's take a look at this code. And I will let you folks out for the night. So we're going to page 21.
So that would be pretty cool, pretty easy to do what you had before with the PIR to sense motion.
Yep.
And instead of saying, hey, turn the light on, to PIR almost sense motion, then turn the light on.
Yeah. Yep. So yeah, well, that's a cool thing. Like with this relay, you could trigger a light on. You could trigger a sprinkler system if you want to really be fun with things. Or that's what you could do. Like, again, I talk about this with security systems, and again, like default systems that are going on, is imagine somebody walks into an environment and they have an orange shirt on. Again, we talked about this with uniforms. So there's something called the Moondream model we just had a class on. And so with that, it's a low resource vision model. So if somebody with an orange shirt walks into an area, you could have it trigger the lights to turn on. If somebody walks into an area without an orange shirt, you could trigger the sprinklers to turn on. And again, you're probably not going to get sued if you turn the sprinklers on, but if you have random people walking through your property and the sprinklers keep getting turned on, they're probably going to stop going into your property. Right? Yeah, that's the kind of interesting stuff that you can do. And
my use case is I got a couple of foxes.
okay, yeah.
Wandering in and
Yeah.
so forth, and my wife wants me to get rid of them.
Yeah.
Let's get them away from the front door.
Yeah.
Kind of thing. So motion, turn on light. I don't want to do anything lethal, right? I just want
Yeah.
Do like a audio of their predator, top predator, like
Yeah.
a sound.
But yeah, detect and then some sort of action based on that, whatever
Yeah.
it is with sound, light, or whatever.
Yeah. Well, but that's the thing too, is like with it, see what's cool about using the vision is so with PIR, it's a very blunt instrument. Basically any object that's a motion, so a dog, a deer, anything that's going to trigger it. The cool part about vision is you could literally say, if fox, do X. And if you walk up, it'll be fine. So you could say like, if you see a fox, like blare an air horn. And if you see me, turn on the light. You know, that type of deal. Yep.
Wouldn't you have to train it to know what fox is?
Well, no, because that's like, as I showed you, well, lava takes 5 minutes. Don't use lava. But there's a model called Moondream. We just did a class on, was it last class? Anyways, we just did a class on Moondream. It's a very small model. And so that actually has pretty good performance. That'll give you a response in, 20 or 30 seconds. So it's like you could say, and again, the nice part about Moondream is it gives you the flexibility of putting in a prompt like you do with this other stuff, but it's much, much faster. So it's good. It's good for troubleshooting. It's good for testing and prototyping, that type of deal. So we take a look at this with the prompt. Let's see here. So, okay, Olama chat, GPIO, we're doing LED, plus we're doing the output device, because the output device is going to be this relay. And then we're doing date time, and so this is what's going to give us our time function. Again, what time is it? We do the LEDs like we did before. Output device, so we're going to the Broadcom pin 10, whatever the board pin is there, and then active high equals true. So basically what this is saying is when it's on, make it high, essentially. Anyways, we have the same speaking stuff as we had before, the same speech to text as we had before, basically the same AI as we had before, same text to speech as we had before, and then we come down here and we start to create a little bit more code. And again, the curious thing is, for all the power that I just showed you, this is 86 lines of code. And it's 86 lines of pretty crappy code, to be honest with you. So we take a look at this. So we're going to look at here, so while true, so LED ready on. So the green light turns on. I say the query, that light goes off, it prints out the query. If the query does not equal error, and hey potato in query. So this is where I create that trigger phrase. And that's a cool part about this system, because again, everybody has Hey Siri, everybody has all these things. And so it's so, like there was that South Park episode where they decided to be real assholes. And so during the entire South Park episode, they just kept saying like, Hey Siri, or Hey like Google or whatever else to mess with your devices. So the cool part about this is that you literally type in what you want your trigger phrase to be. Nobody else has to know what it is. So anyways, we come down here. So for the query, what we're going to do is we're going to replace Hey Potato with nothing. So again, if that query gets sent to the AI, because if you send Hey Potato with it, who knows what the LLM is going to think that means. So we're going to delete it. We don't want that. So basically, we just want the query. We're going to print that out, and then we're going to do the query, the TTS of what the current query is. So you'll notice when it was speaking to us, it didn't say Hey Potato. It only said what the query was. LED processing on. Oh, if end session. Here, right. Hey Potato, end session.
In the session.
So this is I actually left this in here because this is a problem. One of the big things with artificial intelligence is, again, in the modern world, we hear this. Yeah.
I keep responsive
Shut up. One of the issues we get to, again, I don't care how people feel about DEI. Again, as I will say, Silicon Dojo, it's not social justice. It's something along those lines, though. Again, this is free. Anybody can come, whatever. If you hate DEI, just don't tell me about it. One of the reasons that I bring this up, though, is because once you start dealing with artificial intelligence, there becomes a real issue with how your users are going to be interfacing with these systems. You can run into very weird problems that you're simply not expecting, right? When you have an HTML form, it's very easy to tell users, click on this, right click here, left click here, and if you don't do it, you're an idiot. What happens when you start having a system that you're speaking to? And then again, somebody like with me, I have a lisp. So some people realize it, some people don't. It is kind of weird that I do this for a living, but I really do. I have a lisp that I've had since when I was in first grade. They gave me therapy for my lisp, and then they stopped because that's how our education system works. Anyways, so when I say particular words, I do not pronounce them properly. So one of the issues that you can have if I'm using an AI system, what happens if I don't quite pronounce the words perfectly? And so that's one of the things to be thinking about. When you start thinking about these trigger phrases, can everybody say it the way that you think they'll say it? Again, when I came up with this whole thing for end session, I didn't think end session. I have a lisp. I didn't think end session was going to be a problem. But when I try to tell it to end session, you'll see it do a lot of different things. Hey, potato, end session. Come on. Hey, potato, end session.
In the session.
Yeah, see, it does that. See, end session. How hard is that?
I'll keep responsive.
You can say end session. I can say end session. Hey, potato, end session.
End session.
There we go. Now it ended, right? So it worked. Again, your code works perfectly. I wrote the damn code, and I can't get run properly. And again, this is why you need to have a lot of people using your artificial intelligence systems, because the errors that you get back might be things you're not even thinking about. Again, we had in one of the classes that we did, we have a student that comes in, and he's from Russia, and it was interesting. He was talking about like word position in Russian, as far as we are concerned, can be very weird, like where you put words. And so he might talk to an AI system and expect it to interact in a way that it's not going to interact. But anyways, so end of session. So if end of session, or a much better trigger phrase, in query, we're just going to do the exit function. So this exit function kills the Python script. Elif, what time is it in query? So response equals date time dot date time, string, that's multiple pages, there we go. And then basically this is too damn long. And so response equals date time now, dot string time, hour, minute, second. So this is basically just giving us what the hour, minute, second is as the response so that you can spit the response out. Elif light on, we're going to say relay dot on. So we're going to turn the relay on, and response is going to equal light turned on. Again, one of the things to be thinking about with the users is tell them what's supposed to happen so that they know the damn thing triggered, right? Light is supposed to be on. Maybe the light bulb failed. Maybe it's not your code. Maybe the light bulb turned out. Elif light off, relay dot off, response equals light turned off. Else, so if it's not one of these things, send the response, send the value to the query and get the response back. LED processing, print the response, LED answering on, text to speech for whatever the response is, and then LED answering off. Else, so if this does not happen, right? So if there's not an error and there's not a hey potato, else we're going to sleep for 5 seconds. So what that does for us is, again, we want to be thinking about user interface. And so one of the questions we're going to have, especially if this thing is off, is whether it's looping. Is it actually functioning? So having it turn off for half a second and turn back on, that then gives me a blink on my green LED just to show me that my system is still running and it hasn't like frozen up or something. So it should, there you go, see it blinks again. So it just gives me that little blink.
5 seconds or half a second?
That's half a second. Yeah, yeah, you don't want 5 seconds, then it'll whirl. So anyways, and so that's basically the class. The final thing was the face tracking robot. We're not going to talk about that because it died. Oh, go potato. We salute you, potato. You died in line of duty. Anyways, if you take a look at this, basically all this is doing, if you look at the pie-face robot script on page 24 and 25, basically what this shows you is using OpenCV. Essentially what you're doing is you're getting the X coordinates of where a face is detected, you're getting the height of the face, and then based off of that, you're then actually moving the motors, right? So there's motor left and motor right, and then basically you're able to move the motors forward and backward to try to move the actual vehicle itself. It was really cool, and then it went poof. Okay, and yeah, I've had you folks here long enough, anyway, 8:30. Any questions? That's basically the class then.
Do you think it overheated?
What's that?
Do you think it overheated, or it just was a fluke?
No, smoke came out of it. It went poof.
Well, yeah, I'm saying, it hasn't happened before, so probably it'll heat.
Yeah.
People should burn the board.
The board.
Somewhere.
What? Some board. Well, the thing is with it, like when the smoke, again, it literally happened right before class, so I have no time to troubleshoot it. So this is called an H bridge right here. So this H bridge is what actually moves the motors around. And again, smoke came from this area. So it didn't come from the board itself. I think it came from here. And the issue is, I'm not sure I said this. So when you use the use the Raspberry Pi 4, you use this power supply. This is a particular power supply. When you use the Raspberry Pi 5s, they actually have a different power supply that has more power. What I'm wondering is, did that power go directly to the H bridge? And then, to be clear, it shouldn't have. It shouldn't have. But that was the only difference in all the. I've been working with this thing for like 3 days and had zero issue. It only died when I plugged that damn thing into it. So what I'm thinking is maybe too much power went into the H bridge and blew something on that. But that's troubleshooting. Yeah. Yeah.
Awesome.
Yeah. Go. So yeah, you can take the papers. Don't take the 3-ring binders. If you are signed up for the full day class and you're not going to come, please un-RSVP. That's an important one.
Is that going to come on the YouTube or?
The full day class, I don't know, because this is like 2 hours. It's pretty easy to edit and upload. That is going to be a full day class, so maybe I will definitely maybe.
I'm traveling, but I really want to come.
Yeah. Well, my hope with those kind of classes is that we will repeat, especially since we have 30 people on the wait list. My idea is maybe quarterly, like every 3 months. Like what I want to do is like those long, so like with Python, with SQL and Bottle. So SQL and Bottle will be a full day for a database class, and then we're going to have like maybe every month or every month and a half we'll have a full 1 day class, and then those will kind of repeat on some kind of cycle. Yeah. Yeah, there you go. All the bits. Yep. Yeah, you just put it right there.
Python class, you said there's already a wait list?
30 people on the wait list. Yeah. Yeah. So, so that's where I say, we'll probably repeat those. And also, if you're willing to drive that far, I'll probably be doing more in Asheville, because again, I actually live in Asheville. So commuting 15 minutes to an office is a lot easier than this. So we'll be doing a lot more day classes in Asheville too, if you're willing to commute that far. What's that? Oh, yeah.
So I should find your website for the Asheville ones.
So if you go to silicondojo.com.
Not the meetup one.
Yeah, so basically I use Meetup for basically everything. So there is a Asheville Silicon. So if we go Meetup. So if you go to Meetup, so there is a Silicon Dojo Asheville. So this will be for Asheville. So you can sign up for this one, but yeah.
Okay. That's like 45 minutes now? 1.5 hours?
3.5 hours. It's
Oh, you're on the other side.
Asheville. Yeah.